That will go forward to the overall competition for the G3 VVB trophy. But I see there's a Crawley Cup as well that's awarded, the G3 GRO Cup. So I don't know if you want to do that as well.
Yeah, we can do. Mike, G3 GRO Cup.
Very good.
Thank you.
Studying. Have you got the cup there, or is it? Have we got it lined up here somewhere?
It's the plate, isn't it?
It's the plate. There you go. See, it was lying down. There we go. I don't know. I can't read. My glasses are streaming up. No.
It usually lives up there, doesn't it?
Well, we'll present it later. That's
Yes, all right. Now I'll hand it over to Dennis.
Oh, it's hiding up for you lot.
What, are you ready to go?
Which one is it, sir?
Did everybody find their way here okay today? Apart from one person. I know Julian struggled coming overland.
There's probably some calling around Crawley at the moment.
Yeah. Yeah. Was it? All right. Well, I came up from the Isle of Sheppey, and the A249, which is the main. They've found the plate now. So, hang on a moment. Let's bring it up and we'll present it to Jen.
Oh, right. I thought you were talking about A2.
Have you polished it?
It comes in a fine carrier bag.
Fine carrier bag. There you go. Do you want to present it, or shall I? Okay. Yeah, Jen, thank you again for your very nice entry to the competition.
I aim to write an article for Scatterpoint, just based upon that text that I put there, actually, just to describe what we did. Very straightforward, repurposing of an old squirrel from the 90s. I'm going to do some experiments next week, transmit, receive on 10368, I'm sure it'll work. But quite good gain, actually, and good efficiency. It's equivalent to about 60 centimetre dish. Anyway, thank you very much.
Okay, thank you. You can hand that back later. Right, are we ready to go yet?
We are indeed. Let me put that on the live stream so that people can see it. And if you'd like to pass the microphone to
Right, well, this is
they can clip it wherever they like.
Gareth G4X80.
Where would you clip it? That'll do, right?
No, that's last year's. I'm not doing that.
I
again.
just project what I'm given.
That's my one from last year.
Right.
Time machine.
So which one is it then? Crawley MWRT.
Blue box, yeah.
There you go. We'll have that one instead, shall we?
Yeah,
There it is.
Well done. That was the first deliberate mistake.
Do I get a clicker?
You will do as soon as I do this, and I'll test it.
Hope it works.
It always does.
Like it looks, that's not
That's
advanced.
the laser pointer.
That's the laser pointer. Oh, that's handy.
The
Right.
right hand one goes forward, and the left hand one goes back.
I think I can go. What advances it then?
Right,
Oh, forward, yeah.
Forward.
Right.
left, back.
Failed. Listen to the instructions.
After you.
Right. Yeah, I think I'm good to go.
Okay.
You asked for this.
Well, there you go.
Good afternoon, ladies and gentlemen. I describe myself as an enthusiastic amateur with limited technical training, but an endless fascination with almost anything technical. So what follows is a quick walkthrough of something I didn't think would happen very quickly, and that was getting on 10 gig and then 24. But before we start, I'd just like to thank people, because none of this would have really happened if it hadn't been for some key bits of other people's very good work. So I'd like to thank Dave G8GKQ and Colin G4EML for writing the Portsdown software and the Langstone software respectively, and all sorts of other people who've contributed to my voyage since I retired about 6 years ago into getting going on as many bands as I possibly can before I get in a box. So it probably started with a trawl of eBay for nice big PAs for 13 cents to get on the satellite, Oscar 100. And a certain buyer called Bison Electronics popped up there, who clearly has access to a very interesting surplus pile of mobile phone base station stuff. And he started selling the amplifiers. Quite a wide range of stuff that will go with varying degrees of success on 13 SEMS. The one I use at the moment will do 250 watts CW, and another board I bought will do 500 watts of CW. It's got 3 very big devices on it, and it's really quite amazing that I paid £30 for one of those. I used to think that the older amongst us would have enjoyed the World War II surplus and that I'd missed out. But actually I think we're in a time now of even more amazing surplus, because the technology has moved on so far that although I've got 1 watt on 10 gig, it's not really down to me. All I did was put someone else's product in a box and add the peripherals, I suppose you could say. So we're in a very nice place to be. And of course Google, where would we be without Google? Either finding articles that some of you have written, or looking at Scatterpoint, or indeed all the other useful bits of web stuff. And local oscillators, well, back in the day, looking at crystals tripled and then tripled again on boards with pipe cap filters on. I never quite got there. I bought the microwave handbooks a long time ago and read them and thought, yeah, when I retire. By the time I got to retiring, of course, there are other ways of doing it. And an ADF 4351 with its range from 35 to 4.5 gig nearly just makes it so simple. And there are others, of course. I benefited from a group buy, which seems to be quite popular these days. Somebody does the PCB, gets them made in China, and I think JLPCB will even assemble them for you in part. Certainly a lot easier before the component shortages and results, of course. So there'll be some questions. Right, here's what I started with. That silver bit there is a 1 watt Cambridge broadband network, essentially transverter. It takes something in the low gigahertz and coughs it out on 10 gigahertz. To get it to do that, you needed power supplies and a bit of TX-RX switching, a local oscillator, which is one of those ghastly keyboard driven things that don't actually do what they say on the screen, but nevertheless do provide a signal. There's probably a little amplifier in there that feeds the local oscillator port. There's a changeover relay, and there's a nice RX filter, and that feeds a G3 PHO feed. Once again, details found on the internet. I love making things, and that feeds a 65 centimeter dish. And much to my absolute amazement, it actually worked. But it was 200 kilohertz high, so although it appeared to be working, it took a lot of dial spinning before I found the station I was trying to work. But having found them, it was fine. We worked narrowband, first time ever, and then worked DATV. Okay, so that's still currently the 10 gig setup. I was quite pleased with that. 2 stations actually. I swung the beam round from somewhere in Hampshire. It escapes me, sorry. Since been extended to 92 kilometers, digital TV and narrowband, and I've had the output measured at 24 dBm, so it's about half a watt. whether that's the measuring gear, whether it's the relay. It is actually a radial 18 gig rated SMA relay with as short as possible feeders on it as I possibly can manage. But it works. So I then proceeded to do a better job. I bought a preamp, a down east microwave one, and then had the noise factor measured and noise figure, sorry, and it's down to 2.5, which I believe is reasonable. There may be more. Okay, it's in a box, quite a large die-cast box, with another power supply slightly built more robustly, and you can see the, oops, sorry, not forwards. You can see the preamp, the filter, an even better relay. This one has got indicator contacts on it, which I use as TX interlock. The bubble wrap is keeping the CTI crystal oscillator warm or away from drifts. There's an Arduino Nano that programs one of the Greek ADF 4351 oscillator boards lurking under there, and that outputs the required LO. And all the good bits happens inside the bit that Cambridge Broadband Networks made. Thank you very much for that. They went into liquidation, sadly.
Nice filter, Gareth.
Yes, I thought you might recognise that. Thank you very much for that one. So, it's almost plumbing. From this same vendor, Bison Electronics, I noticed this device. It was described as a Wavelab 2 watts brackets QRO. You're not kidding. It's one of those. This is the whole board out of one of their outdoor units. And thanks to the work of several amateurs on the continent and translating a Polish website into English via Google, I found that it could do the same sort of thing. Add a local oscillator, add some power supplies and switching, and away you go. Because this all revolves around having an incredibly flexible IF, i.e. no longer constrained to 144 or 432, which is of course where the talk title came from, my blue box approach to all the microwave bands pretty much, and Adam Pluto. They are about 200 quid now, but when they first came out they were £100 launch price, so I think I've got 4 now. They really are very flexible. If anyone hasn't met them, they're 70 meg to 6 gig transmit capable SDRs with really quite amazing performance. Okay, so all I had to do was find data on the local oscillators required, which it seems are 2352 megahertz for both TX and RX. There's no real benefit in splitting those, I don't think. The Pluto stability, well, like anything that's cheap, you pay somewhere, and they didn't have a very good TXCO on the SDR board to start with. It didn't take long before people launched upgrades to really quite precise ones, and I found one of those upgrades is adequate, so that was one thing. I read all about the issues. That should read 5.1, not 5.0, I think. Stability and purity on the microwave forum, and how to improve it by adding capacitors and a little bit of filtering and that sort of thing. So I've made an attempt at that. I bought one of the incredibly very stable low power consumption crystal oscillators that Alan was selling at Martlesham, and that has proven to be perfectly adequate for SSB. Just a very slight sort of warble on it. It involved an awful lot of Googling, as you can imagine, to sort of tie up stuff in Polish and what the frequencies should be, because there are several different approaches. Somebody had swept all the IFs and the input filters. There are 2 of these modules. One goes straight on 24 gig and the other one, only the PA goes on 24 gig if you bypass the internal filtering. But I'm sure you're aware the size of that filter inside is very small, and people say don't take the lid off. We shall see. Right, this is the second wing and a prayer. The bit I'd point out here, this is the board that was crowdsourced, I suppose you could say. They were sold, I think he ordered about 50 of them, and you could just say, yes, I'd like one, for 15 quid. So it was ready built, 3 voltage regulators, some simple interfacing for the PTT and changeover and some LEDs, and then you hook it up with little daughter boards to one of those modules. Once again, I tried to keep everything as short as possible. It's another 18 gig relay, I'm afraid, but I think those cables are suitable for the job in as much as they are very similar to some Hubert and Schooner things I've seen that have got the same size and the braided outer. Perhaps somebody more qualified could tell me if they're any good or not. But it does output 1 watt, and that's it here in that box. It's supposed to be 2 watts. Some people have turned the PA voltage up, but let's be honest, if it works, there's no point in blowing a almost certainly irreplaceable PA just for the sake of 3 dB or whatever. So there it was, it worked. Then I boxed it, did a proper job. Google got a real beating. It has been measured though recently, 980 milliwatts. Where that's going, I haven't bothered taking it to bits to find out because other things need building first. Noise figure, sorry, been measured at 5 dB. So I probably need a preamp. I have managed to buy one of the last few PCBs that Kuhn was selling along with the active device, but the parts are tiny. So I'm going to need a very quiet, calm day to assemble that. Currently I use it with a 38 centimeter dish, X3 38 gig, but with a birdcage feed. Thank you for that, Dennis. That came from you a couple of years ago. And best DX so far was in the narrowband contest last weekend, 5.9 plus on FM at 100 kilometres. So Woldingham in Surrey to Walbury Hill. So there's plenty spare there, I'd like to think. Okay, the Pluto really is the key to all this. So the local oscillator is on 1808. It's multiplied by 12 inside the Wavelab module. I put a trim adjustment on the crystal reference so that I was able to get it spot on by comparing it with somebody's GPS locked 24 gig signal source. The IF as stated is either the same for Portsdown or for Langstone. The -7 dBm is well within the Pluto's output, so it really does just connect straight in. SMA in and out, possibly not ideal, but the Wavelab module has got SMA on it rather than I think K-type connectors are the next spec up. So I thought, well, if it works for Wavelab, it'll work for me, which it seems to. And then some, I hope, better quality hardline to an SMA transition on the dish. To get the relay to work, I just had to add a transistor inverter to the PTT signal that already existed with the onboard switching. More plumbing, I suppose. That's the inside of the plastic box. Pretty similar to as before. The only addition there is probably that, which is one of those generic amplifiers to raise the local oscillator level to the required drive point. It's the same Wavelab module, and then some cables. No, that's not that. Anyway, bits and pieces. So Wavelab module relay. That's another Arduino Nano on top of an eBay ADF 4351, and that's one of those precision crystal oscillators. It is secured in some way. It looks like it's just hanging there, but it's not. It doesn't look tidy. I'm sort of ashamed to show it almost, but it's proven to be plug it in and work. So reliability is the key. The random orange wire dragging across there to that little thing there, which is a tape level meter, I looked at the diagram of this module, and it's got an RF detector diode on the output, which outputs a negative voltage the more RF it produces. So I measured it and thought, well, I'll just feed that to a meter and connect the meter backwards. So I've now got RF level meter on it, so I know it's actually transmitting some RF. One way of doing it, I suppose. Okay. Any questions at that point? Deadly silence. Okay. I would like to thank again the people who have made this possible, because without their contribution, like the code for the Arduino Nano, Robin wrote that. It basically programs the frequency you want and the output level and then goes to sleep. So that's one source of interference removed, though it's not proved to be a problem. And many others not named. They've all given freely of their time for the benefit of the hobby, so thanks very much for that. And of course, Bison Electronics, they're worth putting on your eBay watch list if you're in the market for almost anything like that. Having said that, it's gone very quiet lately, so wherever he was getting the stuff from, it's either finished or we're just waiting for the next band up to appear in the surplus market. We can but hope, perhaps. Okay. The future. Well, while they were cheap, I bought some spare modules and PCBs and the parts to populate them. Also along the way, I've acquired an Alford slot for 24 gig and one for 10. So although I live in an RF pit, I am just 100 metres off the Greenwich Meridian, southeast London, and a mere 68 metres above sea level. I'd be quite happy to build a beacon and maybe one day hear myself off the moon, or at least hear somebody off the moon and take it from there. Right.
Do you think you'd ever be able to get the 2-watt PA out separately?
I've got two 10-watt PAs. One's a travelling wave tube and the other's a solid state one. The problem is I feel really reluctant to attenuate 1 watt or 24 dBm or whatever down to a milliwatt. But that would be the easiest way. I mean, I could get into the module. It's got a very clear driver chain. I could possibly get in there and put an SMA for pre-drive level. It's sort of on the maybe. So yes, it's possible. There are, of course, other ways which involve a local oscillator and a mixer, and away we go again, driven by the Pluto. Because if you go to the top of an ADF 4351 4.4 gig and then add 6 gig, you're above 10.3. So theoretically, you could just do it with a few pipe cap filters and a mixer. That's what I was thinking. See, you can tell I'm not trained, but I don't mind thinking and imagining and seeing if it works, and if it does, well, that's good. Okay, now that's a fairly short talk, but I did do others of the various other things I've built, which I use in my microwave and other radio hobby, and I'll happily drone on about them if you want. How are you doing for time? I've brought it all with. Have you heard enough? Yeah?
All right, and yeah, thank you, Gareth. That's, what did, yeah? Okay, yeah.
Carry on.
Because one of the talks hasn't turned up, so.
Yeah, all right. Well, that's what I thought. I'll
Yeah.
Could I just
long
ask
as
you're feeding 20 meg precision reference.
yes,
You're using that to drive the input frequency to the ADF 43.
yes, yeah.
Okay. That's fine.
And then I put a trimmer on that so that I can tweak. I don't know. Well, I think I heard at a Harwell talk somebody mentioned how the ADF 4351 works, and the higher the reference frequency, the greater the steps you will end up with. And anyway, I haven't got a stable 100 meg oscillator, so I left it at that. Right, okay. Exhibit A, I suppose you could say. I was asked if I could dream up a simple, cheap, functional solution for aiming microwave dishes that fit the ubiquitous tripods. So here it is, the Tilt-O-Matic. It was published in Scatterpoint a while back. And it was designed to be built by almost anyone, because some people don't have workshop facilities. They might have a jigsaw or a few basic hand tools. Therefore, it needed to be within scope of somebody who can operate a few basic hand tools. It was actually Noel, GTZ, who asked me if I could dream something up. So here it is. I've made two, and two other people at least have made one each, and they both find it adequate for the task. I've had a 60 centimetre dish on there. It's quite happy at that point. It's adaptable. It doesn't have to be this size. You could make it wider, narrower, shorter, longer. You don't have to use plywood, but in terms of cost, it was zero cost because I just happened to have some 12mm plywood. It does use some 3D printed parts, which are about 12 hours worth of printing. So if you know someone with a printer, a bottle of something or some form of bribe would probably get the job done for you. What else? 3D printed parts. It uses an automotive bearing. If any of you have ever worked on cars, or more specifically differentials or wheel bearings, you may have heard of a term called preload, where you actually have to tighten the bearing up to a point where it takes a certain amount of force to actually rotate the shaft the bearing is on, which has always struck me as a horrible way to treat a bearing. Anyway, I thought I can provide the damping by just tightening up the preload. So as well as attaching it, you can alter the preload just by doing that up. And then the dish can still be moved, but it won't sway in the breeze. So that solves that. Now, I thought a large bearing would be quite expensive, but much to my surprise, this one here was about £13 delivered. I mean, it's a very big bit of precision steel for 13 quid. So that's it. There's a little adapter plate that matches your tripod and a few other bits and pieces, and that sits on there, and then you do up that screw there, and that's it. That secures that. Okay, the tilt mechanism is basically that. It's a 6mm thread, courtesy of Screwfix, and some captive nuts, and a turn wheel, and two cheap brass hinges, also from Screwfix, and a coat of lacquer, and that's pretty much it. I am pleased to say, when I made the second one for me, I didn't change anything other than where the actual centre pivot that I'm just putting back together fits. Because the other one was slap bang in the middle, and if you've got a big heavy dish on there, you've got quite an overhang. I thought that's not probably a good idea. Certainly a 60 centimetre dish on one of those huge aluminium brackets they come with. Not the sort of thing you want. Okay, so that's that. What else have I talked about? Yeah, Screwfix studding. There was a bit of backlash on the thread because it's only Screwfix stuff. So what I've done in there is I've used two nuts, but they've been tightened up against each other so that they take the backlash out of the thread. It's hard to explain, but the documentation that goes with that does tell you how to achieve that. Those are the bits and pieces. There's some wedges that go under the hinge to allow you to go negative. The bearing collar, the tripod collar, turn wheels, the pivot bars, and it'll all fit in one go if you want to leave your printer running for 12 hours. no necessity. It doesn't wobble once you do it up. If you're looking at it and thinking, why is it wobbling? There we are. Okay, there is flex at that end, but there is really not much flex at that end where your dish is, so I deemed it adequate. I think that is it. Yeah, that's it on the Tilt-O-Matic. If anyone wants to have a look at it or ask any questions, and
Do you have the files for producing it?
yes, they're on the Scatterpoint files section.
Right.
And if they aren't, just message me and I'll email you them. Right, score 1. Right, okay. And again, we're still awake? You want to hear more? Okay. I mentioned earlier being 200 kilohertz high on 10 gig. I was able to set it accurately, courtesy of Dave G8GKQ, who has a GPS locked source that does 24 gig. Third harmonic, I think he said. So I thought that's rather a handy thing to have, but I'm not spending 150 quid on a Leo Bodnar if I can find another way of doing it. So, the solution Dave had, he bought an ADF 5355 before they became like 150 quid each, or he found it in a bit of surplus gear. I can't remember the story behind that, but those are based on current prices. 300 quid. Well, there must be a better way. I'm sure a lot of you, if you have any interest in HF, may have heard of QRP Labs, who produce a huge range of really well-priced kits. One of which is a thing called a prog rock. Now he brought this out a while back. It's basically the SI 5153 or whatever it is programmable frequency source. But he had binary coded switches to program the frequency. It was a nightmare. Anyway, prog rock 2, you can plug it into your PC, and he's managed to squeeze programming software into it. Although it's very crude, it does work. Same basic things. It'll produce any signal you like up to about 200 megahertz. So I thought, yeah, that'll do. It'll probably wobble a bit, but why not lock it? Because his QLG2 universal GPS will lock the prog rock. It uses up one of the outputs, but you can still have two separately programmed output frequencies. So I thought, right, okay, GPS lock it. That will probably give me something. This was based on some experiments I tried with a Neo 7 GPS, which you can plug into your PC. The uBlocks website's got some wonderful software. You can program up to output any output you like, up to about 15 meg, I think mine would go to. But it wouldn't remember it. And listening to it on 10 meg, it was warbling around all over the place. It was horrible. There's no way you can use that as a reference. And of course, there's lots of talk about phase lock loop in your GPS so that you don't get the jitter and so on. Out of my league, I'm afraid. So I bought the universal GPS. It's universal because it uses anybody's GPS satellite. The Russians, the Chinese, ours, Europe's, USA's one, the lot. So I thought, well, any 1 pulse per second will do, but support the man in his endeavours, so I bought one of his. And I connected it up to a prog rock. And then the development work got what I would describe as interesting, because I used that signal to drive an eBay ADF 4351 board. And the signals that came out of it were, well, broadband. They looked like the sort of noise we all hate on our HF bands, just broadband stuff. You couldn't actually see where the fundamental was. And I couldn't work out where this was coming from until I looked at what was on the board. It has a 100 meg crystal oscillator on the board with a nice little jumper pin to select internal or external, which I did. But of course it left the 100 meg running. And what was happening with hindsight, because it's a CMOS chip it turns out, the ADF, is it was picking up the 100 meg, presumably by capacitive coupling, and the 10 meg, and trying to use that to produce the reference I wanted. So no surprises that the spectrum it was producing was vile. So I disabled a 100 meg oscillator and it all cleaned up. Right, it provides a recognizable signal. I say recognizable because it sounds like this on 24 gig. Okay.
That sounds familiar, Dennis.
When have we heard that?
And what that is the software Hans has written for the GPS correction. You can choose steps because he designed it for HF where it's fine. You just wouldn't notice. Initially, it defaults to like fairly coarse steps. So if I just demo that, if I remove the power and then replace the power. Right, you can see it jumping around now because it's forgotten how close it got. It'll take about 30 seconds or so, but the steps get slowly smaller until it gets to the least significant bit. And then it sits there. To his credit though, once you've got the thing tweaked on frequency, the onboard crystal oscillator for the prog rock is perfectly adequate to find it again without the GPS. Pardon me. The GPS just lets you know that really is the frequency. There we are, the wobble's got less now. Okay, so that's his software working to correct. It does 8 bands, 2 meters all the way up to 24 gig, third harmonic on 10 gigahertz and 7th harmonic on 24. There's another 20 dB amp in there which is used to produce AM modulation if you want, and because there's only 3 data lines to the chip, I've been able to control it from my port stand 4 as well by flicking a 3-pole toggle switch across. So it then becomes a signal generator with variable output and so on. Quite a handy bit of kit. As useful as a quick check, you know, am I on frequency? So people can't blame me for not being where I said I was. So that's what it then does. So theoretically, if you buy anybody's Neo 7 with 1 pulse per second output, a prog rock and an ADF 4351, you could build that warbling monstrosity for 50 quid. Yeah, I wouldn't use it as a beacon, but it does what it says on the tin. It proves I'm where I think I am.
Sounds just like GB3 SE used to sound.
It warbles a bit, but at least it's accurate warbling. Okay, we're not done yet. Anyone asleep? Seeing a couple of eyelids close. There's still more. You okay? I'll carry on? Yeah. Right. Okay, what we have here is a... Turn that round a bit. Okay, where are we? On. Here we go. Right, this is a fortuitous purchase on 2 fronts. One, thanks for the tripod, Jen. It's an absolute beauty. And somebody else was good enough to sell me the CCTV head. Okay. Right, we're good to go. Okay, it's not just a little box. It's been inspired originally by the work of Tom ZR6TG, who's quite a prolific software writer. I think he does it for a living, but he's also got an interest in DATV and has written some very nice software for double decoding from a mini tuner. Okay, the good news is it had 12 volt DC motors in it with 10-turn feedback pots made by Bourne, so it's a real quality bit of gear inside there. It was very easy to adapt to the tripod because the mounting flange just needed a shoulder turning on it. So 10 minutes in the lathe and then 6 holes, and it's on. The tripod does rise up, but I won't bother doing that because it's a bit of a handful. Okay, there is a Raspberry Pi 3 in there which is running a Node-RED dashboard, which ultimately would allow autonomous tracking of the ham TV on the ISS and of course any other satellite, if there's some suitable Raspberry Pi satellite tracking software, which I'm sure there probably is. I've used it for tracking a 1 by 1.1 meter dish which bolts straight on there for portable ops. Here we are, that's the Cat23 convention. So the tripod, you can see, is fully extended. It's clamped to a pallet which is clamped to my roof rails. So you shin up on there with a lightweight ladder, bolt the dish on. The dish is upside down because it reduces the windage significantly, and therefore the load on the head unit, and indeed everything else. I can imagine it would lurch around a bit in the wind. That's the tripod as it is now on ground level. Also aiming at the Oscar satellite. That was the Wimbledon summer camp up on the top of Reigate Hill. That worked well. That is my local radio club's new venue. It's in a car park of a church hall, and was able to just miss the roof and so on. That's the line to Oscar 10, sorry, Oscar 100. Right. Okay, in use we have the Raspberry Pi in there is connected to one of those ubiquitous stepper motor driver boards, L293 or something. But I've also got through diode OR gates an up-down, so I can go up or down and left or right. And when I get close I can slow it right down with a PWM input. So it's actually remarkably easy to line up. I basically use a little angle finder on the boom of the LNB. I think it's 45 degrees, so a spirit level on the angle finder and the angle finder on that. Get that set to level. And then a compass for whatever the satellite's on, 158 or something, I think, degrees. And then search around for the narrowband or the TV beacon. And the more you do it, the easier it gets. Okay, any questions on that? There's more.
What's the biggest dish you've had on it?
I'm happy with the 1 times 1.1. I've got a 1.2 by 1.35, but it's a bit, I don't want to strip the gears and ruin it for the sake of, really, I ought to just build a bigger unit. And I've got some bits that one day, I wouldn't like to push it too far for the sake of that. I mean, I did try the big dish, but I just thought, nah, wing and a prayer, bit too far. Okay. There's more.
I think we're all right now, actually.
Oh.
Sorry, the other talkers turned up. So.
Yeah. Oh right. Okay.
All right, okay. Would you Roger like to do yours next, Chris? Is that all right? Where's old man to change the slides?
Where's he gone? Well, if you run out, I'll do the others.
Okay, yeah, it's all
Be
right.
happy to.
Yeah, fine. Sorry, I didn't realise. I just had signals.
Yeah. No problem.
You all right?
What have we got next?
No, not me. Not me.
In which case, can we have your microphone?
Yes.
Any presentations? No, it's the one that's on the screen. Thank you very much.
Who's going to talk about that then?
Chris's talk.
Oh, right.
Great.
You going to talk? Or is he? You can have your seat while you're doing it.
If you want a stick to put it on, you've got sticks.
You want to talk? Pass it over. Right, I'll do it and I'll jump up.
Just say thank you for Gareth at the moment, and maybe fill in a bit later. Thank you. Now we've got Chris G0FTZ and Roger G8CUB, who are doing a talk about the new 134 gig.
The new exciting 132, 134.
Yeah.
Can I give you the dibber? Forwards, backwards, and we even have a laser.
Do you want to do the dibby bit?
I'd just to say that Chris is suffering from Parkinson's, but he's very kindly agreed to come and put this talk together for us, as he does every year. And then Roger's going to translate for him.
This is Chris's talk. Standby narrator as necessary.
Okay, thank you very much. Cheers, guys.
Right,
Do you want to sit
okay.
down?
Yeah. Okay, folks. The talk today is about the new VK balls, which most of you probably heard about, but not many people read about. We're going to talk about the facilities it may have. Well, as I say, nothing's set in stone. The ball is really vaporware at the moment. Next one, please, Roger.
Should we just click on? Okay.
Right. It's based on the 132 gig balls, which many of you have bought and built and used. Anybody here use it?
Who's on 122? Anybody? Gareth. Dennis.
Right.
Okay.
This new ball is not just 134 added to the existing balls. It's a complete new system. It's been given the opportunity to work well by having a new TRA 045.
So basically this is a new chip that does exactly the same as 122 did, but it will do 134 as well. So this opens a whole new world for us millimetres.
Make a particular note of the little operation in orange at the bottom. That is important. Next one, please, Roger.
Okay.
Right. What we're going to do, give the oversight facilities, what you might expect. Okay. That's the boards, or will be, very compact, very small, very compact. So please.
These are the new ones, aren't they?
They are, yeah.
Yeah. So it looks very similar to the old ones, but a whole load of upgrades, which we'll talk about.
100 meg standard as well.
Yeah.
100 meg, yeah, it's a much improved reference. Okay.
Oh, nice. Quite a complicated circuit, to
Yeah.
say the least. So not the sort of thing you go mucking around with without realising what you're up to.
I'm sure you can all take that in at a glance. And, we'll talk about the features of it, so rather than trying to go around it.
That's one thing, Roger. Right.
Okay. So this is a new chip, the 045. It's pretty well. It's the same footprint as the old one. I think it could go in an old board and be modified slightly. But what they've done is taken on board all the criticisms of the existing 122 and hopefully sort them out, as well as adding 134. So there's an upgraded 100 meg reference, which is I think improved stability, improved phase noise over the original. Original on the board was good, but not as good as it could be. There's an improved synthesizer chip, an ADF 41513, which has got lower phase noise and also do small steps as well. They've improved the regulators so that they are lower noise. They've added a couple of indicators. I can't remember exactly which. I think OL2 shows it's actually in lock. Yeah, no, OL1 shows a source. You can use an external source reference with this. Now with the old ones, lots of people modified them because the actual chip gives INQ out. The number of different people have added. There's been boards available to use the INQ. Because what the INQ does is basically makes it into an image rejection mixer. So effectively gives you around 5 dB improvement. So before you had to actually make your own modifications. What they've done is put this on the board, the IF balance and the quadrature combiner. So this will be a 122 will be a 5 dB or so improvement as is, as well as the lower phase noise references and oscillators. Improve the software. I think there's still 1 or 2 bits that not totally intuitive for our use in the UK, but we'll go over that. But it's greatly improved, and made it so you can easily plug in a 10 meg reference, because before you had to modify the board to do that. And yeah, you can use a GPS reference as before. One of the problems was before is the GPS wasn't great, so it would wander around. You'd end up turning the GPS off to actually use it. Okay, improved frequency control, yeah. Dynamic reference steering algorithm to decrease steering lock time. Yeah, I'm sure I understand that, but not quite. There's easier to use serial output, which means you can get information. I think you can get the GPS information out of the board if it's connected, and it makes if you want to reprogram it, it makes that easier. It's a wider voltage range, isn't it, Chris? Yes. Yeah. Yes, that's the increased serial output range. Yeah, display the hex data on the serial port. Yeah, that's useful. So basically, what they've made it is compatible with the existing 122 on the first 3 channels, or first 8 channels. So if you dial channel 5, it will be the same as the existing 122 to make it relatively easy to do. But then they've added the 134 on the next 8 channels. What have we got? We've got brownout detection, improved control operation. Okay, so there's a whole series of improvements, and the criticisms that have been fed into, I think into Tim, they've made use of. One thing they've looked at closely is the feed horn that goes on top of the chip. If you know anything about the chip, there's an offset transmit antenna and a receive antenna. So anything's a little bit of a compromise, and it's going to be even more of a compromise when you're using it on 2 different bands as well. But as I understand it, I've not seen any information on it, they have made serious improvements on the coupler and the feed horn. Right. Yeah. Okay. So these are the channels, which again are these are the 122 channels, which coincide with the existing ones. I'm one of the people that have been using sort of 122 before these came out, so we've come up with a number of frequencies that have been in use in the UK for a while, and we use 122.4, so that's all our older equipment, which is still synthesized, but we had to sort of persuade the VK boards to work on the same frequencies. So channels 4 and 5 are what we use currently normally as our channels of operation, and if somebody wants to work me with my system that's not the VK system, they have to switch between them, the transmit receive, to use 122.4. 134 channels are all new, of course. Again, we use, this is like, it's grown over time. I think it's somebody had proposed some very odd 134 gig frequencies, and 134.928 I think, but we quickly gave up on that and chose, it came from the Elcom synthesizers that are available, what they'd actually come out on, and again we'd set on 134.4. It's actually a nice multiple up as well from 96 gigs, and makes it easy. 96, no, it's quite right, but yeah. So the channels we're interested in there are the 8 and 9 to give the lowest frequency, and the one usually the third line down for the 134. The top one, sorry, the top one A for 134 on transmit, and the other one for receive. The line at the bottom, no, it's like, yeah, the one, no, it's not the one. What one limitation is for the chip is it won't necessarily go to 134.4. We hope they do, but we've had to allow for the fact that a few of them are only going to work just up to 134. So that's the we came up with the idea of to use 134.00.1 as being sort of just inside the band, and hopefully all the 045 devices will work on that.
Call that 134 low, that frequency. Right, 134 normal. 134 normal.
Right. The L and H.
Yeah.
Thank you, Chris. Are you happy, Michael?
Yeah. The IF, incidentally, you know that the IF was a pain on the old board because around 144.0 on 817 you had horrible Verzi. You remember that?
Yeah, a lot of us who used it found that the problem, so yes.
Got rid of that by moving the IF to 144.1. Also, John surveying his 290 didn't come out of band.
Yeah, so with the 290, if it was a bit low, it dropped off the end of the band and you couldn't use it. So it's quite a good idea to move the IF to 144.1. Yeah, these are 2 extra LEDs I've added, and I think Chris said the first one shows what the source is. So if you're using external reference, I don't know which way around it works, but
5 seconds, 5 Hz display. 10 megs or 1 pps for GPS.
Right. Okay. So the LED will flash. Right?
Yeah.
So the LED will flash depending on the source or GPS, and the second one is just shows the synthesizer is locked. Do you want to say about the beacon mode?
That's okay.
Right. Okay. So what I've added is there's basically more characters available, so you can, for the beacon mode, you can put in your call sign, locator, or anything else you want to add in there, which is quite useful. Yeah, so the beacon goes to carrier in between, is that right? Yeah, so
That's it. So we'll go to carrier.
So that makes it a little bit easier to work out what it's doing and to sort of get it on frequency. Yep, they've made this provision for an external 10 meg oscillator. So I think pretty well all of us had used the 122, the old 122, has modified them for external reference. So this is there already, ready to go. But the onboard oscillator, well, we'll find out when we get it. But we believe it's going to be really good. This is the other pain with the old board. They had a regulator that was stuck up. It really needed heat sinking, and it was stuck up in the wrong way in terms if you wanted to put the whole board in a box with the feed horn. So I and quite a few other people, when they removed the old regulator, it actually you actually unsoldered one of the other SMD components, and yeah, it was a problem. So they've thought about it this time and just kept the regulator off board. The FM mod here.
Off you go.
Yeah. Okay. What the FM onboard modulator is a fixed deviation, but presumably they've set it up so it's sort of pretty well right for 122 and 134. We tend not to get too critical in terms of millimetre working. As long as we can communicate, we're not going to have a half-hour rag chew, which is something I'll talk about. Okay, so use a new synthesizer running at 2 gigs, which has got the improved phase noise and smaller frequency steps. So yeah, so this is just improvement in phase noise, really, isn't it, on the whole thing?
It's the last bit that really applies, I think. the default is should not remove, change the frequencies unless you have to.
Yeah. So what you've got that whole list of frequencies. So basically, we suggest you stick with it, but the facility is there to program it to something different. So this is the where we gain on the receive performance by using the INQ to effectively produce an image rejection mixer. So we're getting rid of the unwanted product. So that gives around 5 dB. Probably with improved phase noise, we're gaining further. So certainly somewhere between 6 and 10 dB improvements likely on a unmodified 122 board. I'd say my very expensive put together non-VK system is about on a par of the old VK system. So this means it's going to be better than what I've got that costs lots of blood, sweat, tears and money. Yeah, we haven't got a picture of the actual feed horns they're going to use yet, but there will be improved feed horns. I think one of those is one of Neil's, isn't it? The brass one. Yeah, it's one of the brass one there. Neil DBN, G4 DBN, did his version. Yeah, so there'll probably be alternatives, but I'm looking forward that the new VK one's going to have less loss. Again, that's all the bits that go around the board. Probably go through the list easier, won't it? So it's quite a lot there, but there are sort of normal sort of headers to get the signals out. So basically, there's we've got DC control, microphone in. I think it's just for like you suggest use like an electret microphone. The side tone cut out. Receive data. That's only if you want to look at something, isn't it, really?
Microphone. I use 817 ZIF, and I modified the microphone, which you don't actually need to have an etcher insert to run off of the internal modulator.
Use the 817 microphone.
Yeah.
Yeah. Okay. So microphone isn't critical. That's a good way of doing it. So what happens? You end up with, we use 817 or whatever. The 817 is just really there on receive. If you can be clever and use the microphone, it makes it neat. Okay. So there's basically everything that was there before. So you've got to take the connections out from the header. Okay, Barry G8AGN made a very useful display, because one of the problems with the old 122 was actually total confusion on what frequency you were, on what it was doing. To make that easy, he did a nice little, I think Arduino and a display, and that helped greatly. So what he said is that there'll be a simple software change to use the new 134 board, which will be great. Yeah, all the confusion was as whether we use on A, B, and certainly make it even more complicated where you're working, people like me, that run simplex 122.4. Yeah, it's a much more robust serial port on this. It will take any voltage, and that it's there to program if you need to, and also you've got the GPS output if you want to make use of it, assuming you've got the GPS connected. Right. Yeah, so this is what Chris has been looking at, and he has very interestingly decided that there is a quiet potential of errors going between 122 and 134, particularly if we want to stick to our sort of adopted band plan of 122.4, 134.4. So he's come up with a nice little relay switching bit that we very simple. We'll put it in the next scatter point with some a few bits from this talk, if you're happy with that, Chris. So they'll make life easy. Okay, so we hope these boards are going to be available Christmas, New Year. Yeah, and they're not going to be £5 unfortunately. I think we can appreciate the huge effort they've put in to doing it, and also the price of the chip, as chips have gone up quite dramatically, and the boards and production. But
Is that Australian dollars or
we think that's American now. Yeah, yeah. It sounds like an awful lot of money, but if you try and do it another way, if you try and build yourself a 122, 134 system with bits and pieces you buy off eBay or wherever, you'll be spending a lot more than $500. So it's whether you want to do it, but yeah. Okay, so yeah, that's what we've already said. They've put huge effort into doing this. We hope. I mean, I think it's great to see quite a few people out with 122 and doing reasonable distances, and it's made a lot of getting into antenna design, antenna optimization, and it's all made it all interesting. And we look forward to doing more on 134 as well. And from my experience, there's a huge advantage of 134 because 134 gigs hasn't got the oxygen loss of 122. So when we did our sort of 52 kilometres, the signals on 134 were quite good. I mean, I did work out the improvement. I think it was 12 or 15 dB higher on 134, the signals. So they were very readable, solid FM signals on 134, and certainly trying to receive the VK board as it is, which is probably only putting about 100 microwatts or so after the losses in the horn. It was only just about be able to find it on 122. So this is going to be huge, improving in not just the fact you've got a new band, but you'll be able to improve the distances possible on 122 because you better do the alignment on 134 first with the lower losses.
And the other thing is, of course, you've got the advantage of a pre-impulse on 134, you have on 122, and the same sort of power, 0.5 milliwatt.
Yeah, I mean, you could not put together something yourself. Preamps aren't available for 122 and 134, so and the fact you can do this image rejection mixing is making it a very potent system. 0.5 milliwatt is really good. I mean, we hope they've reduced the losses in the coupler, but even 0.5 milliwatt is quite serious. Chris and I did 134 over 0.5 kilometre originally when we were using 10 microwatts. So 500 microwatts. Wow, that's power. Okay, anything else?
That's it.
Okay, thank you for listening.
I think there's one more, yeah.
Oh, yes.
Okay, all right, yes. They've just announced a 240 gig version. There's no technical information yet. It looks the same profile. So.
Are these all aimed at vehicle?
Yeah, they're vehicle radar. Silicon radar has been taken over by Indie Semiconductor in the States, and they're aimed at the 240 gigs comes up for more precise radar, vehicle radar.
Any idea how much the chips alone would cost?
The original chips weren't that expensive. I bought I think about half a dozen of the original 122 ones. I think they were about, from memory, about $40 or $50.
So they're only normal edge mounts QFPs, aren't they?
Yeah.
No problem hand soldering them.
No. Yeah. I think it's gone up quite a lot. But yes, we have a quick discussion on hand about whether you could actually use the old boards and drop the new chips in, which is one thought. But okay. So. Another year or so, we might be doing the 240 gig version. Yeah.
The 122 and 240 are both ISM bands.
Yeah, 122, 240 is ISM, so yeah.
ISM is my flight zone for adjusting bands, of course.
Right,
Okay.
okay, thank you very much.
Thank you.
Thank you very much, Roger.
Just any questions?
No? Okay, fine, thank you very much. Do you want a quick coffee break or before you go, or you're okay?
We can do like 5 minutes or something.
Yeah. Okay. If you want a tea break or something quickly.
Get my props.
Sorry about that.
No worries. I just extended it.
Yeah.
Yeah, to fill the gap, and if there is a gap, I can.
It's off a bit of police here.
M0JUR. M0JUR. Yeah, Maris.
Nothing on there. Is it a PowerPoint?
Yeah, it's PDF.
Sorry?
It's PDF.
Oh, it's PDF. You can do that.
It's only got 2 views. Be careful what you yeah, and also make sure you buy only 2 cores. That's another thing he pointed out.
It never even works.
Yeah, you get your face more magnetic material.
Laser.
That was just pointed by hands and small.
Pointer is the one in the middle.
Oh, okay.
No, the button right in the middle.
Ah, that one, yeah.
But
Because at this distance, I probably won't.
remember, people who are watching on YouTube
Yeah.
see the laser pointer.
Hold on, had something here. That no.
Yeah, exactly.
Two modules, which was strange, they both seem to do it.
Do you want any more room, or are you all right?
That's fine. Yeah.
You got enough?
Yeah, I've got enough.
Like the casting, did you make that?
Do it? No, that one is not mine. That's just some scrap I picked up from our make space, but it's. We actually been doing. I've made something like that, just smaller. Yeah.
Oh, right, yeah. Well, that's just what we like, little ones like that. For, putting preamps in and such like.
Yeah.
I'm waiting for you to get yours going so we can do some testing then.
It's going, just got to put it in a dish in front of it. A nice shiny dish you can work.
Nobody nearby me to play with. I'm up to about 6 kilometres now.
I've actually got it.
I've done 4 kilometres. Sorry, 6. That was with just the bare horn, the old little horn that they had at one end of the dish. That worked really well. It's about 10 Once you line it up, it's all
You all right then?
Yep.
Give us a few more minutes.
Yeah, sure.
So your rain exercise didn't happen then?
It did happen, but I ended up being only necessary for a couple of hours at the very beginning. Yeah.
I could see something that looked like a pyramid on the horizon. I couldn't work out what it was. Then I went up to the north there and I found it. There is somebody built a bloody pyramid on the side of the dam. I thought, oh, that's what I was seeing. So that was definitely on.
Now, if I was to say them all on 10 of them, the dish will give you scale. Get them all behind you. Let it go.
Quite what maybe one, but it's getting there.
Sit with this. What do you want me to flog those for?
They know the right usage of their own battery.
South Downs is all the same, isn't it? It's not easy to see, but there's a dip of work.
If you put a saw across that battery, you'll deliver at least 15,000 amps. Yeah, you could. Yeah, very briefly. Very briefly. But the point is, it ain't going to interrupt it, is it? That's 50 quid. So when they say drop in replacement, no. Everything drop in about them. They do normally about overvoltage, not so the current. But normally the BMS there was their inspection and down to all the sorts of and it won't very different. Yes, and that's what I'm saying. They will find because then what you do. But the point is, they're not dropping the price.
So when you measure something 15 gigs, how accurate is it?
Fuse doesn't take the kit.
Take it fuse
Take the kit. Take the that's what TCAS fuse does. Well, you get a little housing there, little bolt straight on the series parallel, you want to fuse series shape. You don't need to use each battery. You know, you want 24 volts instead of 2 in the series. You only need to fuse the shape.
How much of their time is
But yeah, it's well, yeah, because I wrote to well known American Marine industry provides regs on spec. Surely.
It's like, you know, you want to get some RS, get it, and it's there.
Exactly. This is what I'm saying. It costs more to put an hour wasting everyone's time than it would have done the time you put.
But they are all sophisticated.
Well, They didn't have that. Because that was
Right, gentlemen, if we where's the information on this on the website?
Where are we on the website?
On the UK microwave. I'm just going to mention it, how fast is the business.
And it wouldn't work for us.
That's still good.
We've got multiple POs.
T-shirts and your fleeces. Seats, please.
Do you do the scaffold? Do you actually do the scaffold?
Right, I'm just going to do a quick plug for the UK microwave T-shirts, which are mentioned on in our website, and that our secretary recently brought one. He ordered it on Ordered it on Thursday, and it arrived on Saturday morning in the post. So you can't do better than that. So there you go. Stand up, John. Take a bow. Right. Thank you very much. Right, just to bring your attention, this is Marek, N0JUR. He's into making things using strange methods. That's all I can, to me anyway. So, round to you. Thanks for coming up with it.
Thank you, Dennis. Thank you guys for having me here. And I should start with a disclaimer that your full name is Neil, Robin, Andy or something, or one of the usual suspects. I'll just be pretending you're not here while being secretly worried that you're going to correct me on something. For everybody else, well, just basically want to talk about mostly about some of my projects, but largely in the context of how you can use the makerspace to do something more effectively or possibly even more cheaply than just going at it completely alone. A few words of me, since I am on the non-average side of my 50s, and I've only been licensed for 2 years officially, so I am a particle physicist by training, experimental one. If you haven't seen a particle detector like this one, this is like the ultimate botch job. Costs millions of dollars or euros or pounds or whatever, made in series of one, made by people who may or may not have experience in electronics, programming or anything like that. And just to give you an example, when I worked on one of the experiments on the Brookhaven lab on Long Island, we had this detector which cost, like the central part of it cost about $30 million. And it had it's a high voltage, what is called time projection chamber. So it's run on the between 10 and 2 kilovolts, the electrodes. The thing is, the LabVIEW control system for that did not, somehow people messed this up, and they didn't have proper limiters on the value. So literally, when you were changing the voltage to ramp the machine up, we literally had the shift leader one day launched at the operator trainee who put 20 kilovolts in the place of 2 because he forgot to delete other things in the box. Because had that guy pressed that button, a lot of people, including the US Department of Energy, would have been very unhappy. Anyway, so I am particle physicist by training, but I've always been very much on the computing side, so I consider myself a high-performance computing bastard operator from hell, which is a term some of the older ones might recall, but in people who work with me and currently at Cambridge Faculty of Mathematics can probably relate to. And I do tinker a lot. I mean, I kind of was thinking, if I was thinking like 8 or 9 when I decided to see what my dad's brand new digital multimeter would do when subject to different kind of outputs. As it turns out, the diode tester mode does not do very well on AC mains. It was a nice flash. Anyway, I am also one of the people who keep this weird Linux distribution that it builds everything from source rather than providing binary packages, well, relatively up to date. I actually started getting involved in amateur radio in the early noughties because paragliding use, which back then everybody basically said no, but it was like at one point I flew pretty close to a major airport in back home in DL, and the assumption was we stay out of the airspace and we don't interfere with their transmissions. They are going to pretend we're not there in spite of having no licenses at all. And of course, depending on the country, still at the moment you actually can't use your amateur radio license in airborne. So it was always a bit of a gray area, and yeah. But actually then the university came, more of the university came and so on and so on. I got quite distracted, and then during the early days of pandemic, well, first I kind of visited National Radio Center while doing other stuff at Bletchley, and then they kind of why don't you look at that? And I figured, okay, actually with my degree I should be able to pass that pretty quickly. And yeah, during the pandemic I basically went, I did foundation and intermediate in one session, a month later I did full, so yeah, happened. I'm also a member and a trainer for some of the equipment at Makerspace in Cambridge, which is called Make Space without an R. Not a typo. And one problem I've got with all this tinkering and work, I kind of got this problem with this QSO thingy, but I honestly will get there in the end, yeah. Right, so what is a there's a typo here, this should be with an R. What is a makerspace? So there is a website that's actually talking about makerspaces in libraries. It's the definition they use on gov.uk, on the relevant gov.uk page, is that is a place where people gather to co-create, share resources and so on and so on. A guy from our makerspace in Cambridge summarized that it's like a gym for equipment, which our directors say it's half right in the sense that, yeah, you pay your membership and then you can get all the equipment to use, but it kind of neglects on the community part of things. And now one of our directors, the same guy who made a comment on that, says that makespace is what you make of it, which is to a large degree true, because at least our makerspace is run largely by the members who decide what kind of equipment we need. Of course, it has to be vetted by the management. If somebody decides to buy a £20,000 machine that one person will use, that's not going to fly. But if there is a need and interest, then definitely you just write a proposal that's reviewed and hopefully the machine gets done. So makerspaces generally come in a lot of different types. So there are really tiny ones, like I mentioned, this library project, where essentially the government gives some money to public libraries to fund like tiny makerspaces on site, and there's quite an impressive list of those these days actually. There's the medium-sized ones, which I think was the Cambridge one fits, and there is this kind of massive ones with hundreds of machines in a rented warehouse and so on, which are like mini factories. And the attitude to what people do in those places also varies. In Cambridge, we really focus a lot on an enthusiastic approach. A lot of people are interested in stuff and they get together and talk. There is another makerspace not far from here and not far from Cambridge, and I'm going to mention their name, which is a specific quest. This is not a place for amateur. We get here to earn money by our projects. I'm not so sure what to think about this kind of attitude, but there you go. They run it if people want to work there. Common pattern is basically, like I said, there are different types, but generally you paid some membership fee and that gives you access to what the makerspace has to offer, either for free or at a pretty discounted rate. So in our case, the machines are largely free. I think only the CNC router you have to pay for every use because of maintenance costs. Materials are highly discounted because they got bought in bulk and we've got some additional discounts. And of course you can use the space, like some people actually use our Makespace workshop as like basically they work from there. They make calls, they talk to their customers and so on. Important thing is always that you've got some social food / coffee / coke place, and kind of joking that it's always included, but I think it's quite an important place because people do sometimes just take a break and sit and chat. So this is what it looks like in Cambridge. This is the main room. We've also got the classroom where the 3D printers currently are. This is a fairly old picture, so they're still in this one. Then behind on the left, there's a secure workshop where all the really dangerous equipment sits, so that's more controlled. And, well, kitchen is up there on the right. There's actually a sewing room up there as well, because we've actually got some people who have made quite successful businesses making theatrical clothes, leather stuff like purses, and so yeah, quite a lot of things going on. Sorry, I'll not run that too fast. So it's a very strongly community oriented. We do host quite a lot of events for other people. Essentially, if you're a member, you can get rent the classroom in the makespace for no charge, as long as something if it's related to some making of anything, you can use it. So people run a lot of projects like the Coder Dojo, so this thing where kids learn to program. We've got the Robot Club more recently. Well, I think it was before the pandemic too, but it restarted relatively recently, where people build robots and try to make them do something. We've got a CAD group, which is, I think, quite important for a lot of people. As I mentioned, we have got there is a core team, but it's actually very small. I think it's like 4 or 5 people. So everybody else is just volunteers who are members at the same time, and they run the trainings, they organize the equipment maintenance, and so on. And as I already jumped ahead of that, and we've got this poster on the wall, which is something I think a lot of people among us can very much relate to. So yeah. Moving on. So why do we actually need a makerspace? Some of the more obvious and possibly less obvious reasons. So of course, a lot of this equipment is bloody expensive. And well, if you can afford that, good for you. Probably most of us can't, at least, or at least might not be able to justify to the spouse that we want to buy a 3D printer for £20,000. Of course, another thing is that you've got all these nasty things that come with running this kind of equipment, or that you actually need to have your things powered from 3-phase mains, which you may or may not have, and taking like tens of kilowatts running it. And well, even some 3D printer filaments, they actually produce small amounts of toxic fumes when you run them. Laser cutter is a completely, there are a lot of materials. If you laser cut them, they're going to produce toxic fumes. So yeah. And of course, somebody has to maintain that. Some of the things are more complicated, some are not. And as I already mentioned, consumables. So if you buy them in bulk, they are definitely going to be cheaper. And last but not least, something that might perhaps be obvious to some people. So yeah, it might look like a Minuteman nuclear missile silo somewhere in northern United States, but it's of course our average QTH. You've got masts for these big antennas, massive workshop, and so on. And then I woke up, and that's my QTH, which is about ½ meter square here, combined with a desk, another ½ meter square, which I have to share between soldering, computer, pretty much everything. So yeah, having room for all this stuff, especially the larger machines like mills or lathes, and it's not an insignificant matter for, I expect, a lot of us. Moving on, so I'm going to go through a little different things we have, largely in the context of what we have at our makespace, but just kind of give you an idea as what I have been using them for and what you could use them for. So 3D printers, essentially there are tons of different types of 3D printers. What people normally think about when they talk, say, 3D printer is the fused deposition modeling, or FDM 3D printer. There's also another acronym, FFF. I keep forgetting what that one means, because basically it's, in practice, it's the same thing as FDM. There are some differences, but it's more like historic. It tends to be that the corporate people tend to use FFF when they describe their printers, but mostly it's the same thing. So like I said, this is the default type, which basically works that you've got this bigger roll or rolls of filament, which then it's not visible here, but there's like a heated nozzle somewhere near the top, which gets moved into directions by stepper motors. And that deposits the molten filament on the print bed, which also goes up and down, layer by layer. And the nice thing about that is a fairly simple design. Actually, there are tons of examples on the web how you can make your own 3D printer without too much complication. And you can actually use, depending of course how you build your printer or what kind of buy and how much money you spend on it. This is not a cheap one. This is actually one that my work has got. Makespace has got slightly less complicated ones, although also Ultimakers. They can print a lot of stuff. So most commonly people print in PLA or ABS or PETG, which is kind of various plastic polymers, but there is kind of filaments are actually based on wood chippings, which give you this really nice wood finish, even though they're still resin-like. Yes, you can print in steel or titanium. I have seen titanium ready 3D printer at CERN when I worked there. Of course, they didn't let me touch it. Hell no. And I've actually seen, not live, but people at CERN showed us pictures of that. So there are some places in Africa where they 3D print buildings in concrete, which is bloody amazing, because that's a kind of machine the size of let's say like a big digger, yeah. But just a 3D printer with concrete. So yeah, there are different sizes. These are roughly to scale if you compare them. So this is like about A4 sized, the whole thing. And this comes from a kit. You can build it yourself. It costs about $300-400 if I remember correctly. There's a previous model which was made of wood. This one is metal because the head is going to be a bit more variable. And then the comparison, you've got this thing, which is an enclosure. It can do multiple nozzles. It's got this extra component at the bottom which allows you to automatically switch between filaments while printing. And actually even more expensive. I'm not going to mention those, at least not yet. Nice thing is that since this is a fairly well-established technology with a lot of people doing homebrew printers, the software for running those and for creating prints is largely open source these days. And quite a few of them are actually, in fact, open hardware as well. Some of the disadvantages is that they give you this very characteristic surface texture, which probably you're very much familiar with. Let's see if I can find a nicely visible example here. Or just pass it around, just try to be careful. You can see that very, very clear line patterns, because essentially you've got those, essentially it's deposited layer by layers. The layers are typically in the order of 1.2 or 0.2 or 0.1 in that order millimeters. That's already sufficient to be visible. And that also leads to certain structural quirks, namely the strength of this material within a single layer is going to be much higher than between layers. So if you try to bend it in the wrong direction, it will just snap. Another fun thing that people personally don't talk about too often, if you somehow manage to snag on the end where the filament actually ended while printing, it will gradually unwind. I've got like a coffee funnel for my mocha pot at home, and you can see it's gradually losing bits and bits from the end. Of course, this was so cheap that I can when it runs out, I'll just replace it. But and there are more structural quirks, and there's this temperamentality. The problem is it depends a lot on what kind of printer you have got, whether it's the highly professional one with an enclosure or a homemade one. These are very sensitive to the temperature of both the nozzle and the print bed. Some materials are more annoying than the others to work with, because ABS, for instance, which is what that box is made of, it has a tendency to get itself unstuck from the print bed, so you end up getting things look like this. Of course, people have got different tricks of dealing with that, which is, for instance, you put a glue stick on the print bed just before printing. On the other hand, if you put a glue stick on a printer which you use for PLA, that's okay. It's going to stick initially on the first run, but then after that it's not going to stick. PLA, for instance, you don't actually normally put glue stick on. You just leave the layer of PLA from previous prints on the glass. And yeah, different materials, they can be quite naughty, depending what temperature you run them at. Switching between different materials on the printer is generally, okay, it's possible, but it leads to trouble. You end up having a bit of different filaments mixing inside the nozzle, so then you have to get a clog up and so on. At our maker space, we actually have dedicated print. We've got one dedicated one. I think it's two and three now because one of them broke. But we have some printers which are dedicated to PLA or TPU, which I'm not going to talk about. But they run at similar temperatures, and we've got separate sets which is for ABS and ABS only. So yeah, basically it's like, I wouldn't say that's what you get for what you paid for, because you can get nice results with the cheap ones. It's just that they may or may not give you a lot of grief while getting these good results. If you ever get one of these, make yourself, do yourself a favor, build yourself an enclosure, because control the ambient temperature is very much a deciding factor in a lot of the issues I've just mentioned. Okay, so what can you actually use this kind of thing for? So I've already passed you that. That's my soldering iron box. So basically, generally you don't have to design those things yourself a lot, because there are websites like Thingiverse where you can get these STLs for loading into your slicer, but of course you can design it because it's all empty, open in documented formats. So that one is actually from Thingiverse, although you might have noticed that I ended up replacing the original hinge with something I got from B&Q, because the original hinge was also ABS with a metal rod stuck, and it just snapped off after like a week of use. Although, of course, those hinges are not expensive, and now it's been working very nicely. Yeah. So this is an example, something related to what I've been looking for recently. I needed a new LNB holder for my Q100 rig. This is a website called STL Finder, which searches for several of those sites where people upload this kind of designs. Some of them are free, some of them you have to pay for, but usually they are not expensive. So if you find something nice, it works. So you can see, okay, this is not visible at this resolution in this screen, but basically it says like it's about 65,000 matches for the term LNB bracket. So yeah, some of them are, there's some repetition, and of course not everything matches, because for instance here you've got a cover rather than a bracket, but There are tons of things to look for. Look for and so on. You can choose. This, some of you might have known, this is the Subnox rotator version 3, which is this project for enabling, the idea that people are going to establish space radio stations based on very simple Raspberry Pi systems. And a lot of parts in the Subnox are designed to be 3D printed, so all those gears and so on. And yes, it does in fact work pretty well for this kind of solution. Probably wouldn't do heavy duty equipment, but for this kind of light duty antennas, like possibly a pair of Yagis, it's quite enough. And there are in fact ways of addressing the more heavy duty applications that I'll mention shortly. That's my Q100 dish head, which is everything that's not black from this direction onwards, except for the pot itself, it's 3D printed. This is all done in PLA, which is the supposedly green filament, in the sense that it is sort of biodegradable. You have to keep it, I think, for 5 days at a temperature, I think 120 degrees Celsius, and then it nicely decays. So it's not something you throw into a compost to biodegrade, but it's relatively easy to get rid of when you actually have a place that processes that. And the nice thing about PLA, unlike some of the other filaments, is that it's got fairly good UV resistance. So just to make it clear, I did most of it in translucent plastic, so it either lets the light through, or once the offset doesn't absorb too much. And then slap some acrylic varnish on top of it to protect it from humidity. And yeah, so this is this guy from Germany. I forgot his call sign, but I think I advertised his works on the mailing list a couple of years ago when Konrad Kostecki was asking about that. So basically this is the rain cover. As you can see, there is a cover for the bullseye, and actually the cap in here, that's also 3D printed because I already got a pre-cut hole, which actually helps hold the waveguide more in place. And then here I've actually got several bits, so there's like an extension part to keep the potty higher above the arm, which incidentally you can see has also got the thing for those funny LNBs for 10 or 24 gigahertz, so it can be, just swap it around and it works. And since my dish had a different holder, I also 3D printed that. So one problem is that actually this thing, I didn't put enough infill. So basically you print, you don't want to waste too much plastic, so a lot of space, some of this is empty space inside. Decide how much you want, and basically when in this March, the dish toppled over because of the high winds, and basically that thing snapped right in the thing, and I haven't been able to locate this. I forgot to save this design, and it must have been proprietary because I can't find it on the Thingiverse anymore. Of course, it's not a big deal. I just have to take one of the existing other ones and just scale this up to a larger arm. But yeah, another recommendation: keep your archive those things. So yeah, okay, I missed one. So there's going to move on to the slides. And some other ideas. This is for next. This, okay, I was going to show you something else. Some of the fancy, more troublesome connectors. Let's say you want to put your power poles in a box. So yeah, there is this commercial holders for those, but I found them quite difficult to come by, and like on eBay they have only seen the 3D printed ones, funnily enough. And they're relatively expensive. And there is a design for this kind of really this size, large connector for a pair of power poles with 2 holes so you can attach it to the case. I had it with me, but in the end I must have dropped it when I was bringing the box to the case to the car. So this is basically a similar idea. I basically took that original design of the holder and integrated it into the design for this whole casing. So basically it's got this plastic extending bit here to keep the power pole more stable, which is keyed. So basically they're locked in place, works pretty well. Moving on, so this is one of the Dell server power supplies modified for 13.8 volts. And of course I want to have the power poles. This is the output for the standard always on 5 volts switch, and of course I wanted to hide all this dead back soldering I did to mod it for 13.8. And yeah, that's also basically this thing I just designed by myself, and I've got it saved in parametric form, so when I change the switch size or whatnot, I can always modify that. That's another thing. Anything else? I think that's going to be pretty much it as far as FDM examples are concerned. So yeah, there are different things you can do, but there are in fact other types of 3D printers than FDMs. I've specifically written just by acronyms because A, it's not important what exactly all of them mean, and 2, because it sounds more impressive when you've got all those 3-letter TLAs. So yeah, but there are different types. They do slightly different things, or possibly quite different things. and as a result they give you different material properties. One problem with non-FDMs is that since they tend to be less common, usually you rely on proprietary hardware, proprietary software, and there are some quirks I'll mention in a bit, and they do tend to be more expensive. So one example is this is a Forge Mark II, which we do have at MakeSpace, and that's the £20,000 3D printer. The thing what it does, it is still essentially an FDM printer, but it allows you to combine different types of filaments. Because multi-nozzle machines with same type of filament, that's normal. Expensive but normal. This one does two types. So you can actually see the box with PLA, actually it's the proprietary version of PLA, but there's a big plastic box in the back with a tube coming into the printer. But this is a spool of carbon fiber. So you can do different ones. We use carbon fiber, but there's also Kevlar. I think there are some other reinforcement materials you can use. And they claim that by doing the reinforcements of your PLA parts right, you can achieve aluminium strength in your 3D printed parts. And this is actually, I've got one of these. So this is this PA for this 2.4 gigahertz amp I was going to bring, but ended up not having time to pick up because right now I've got quite a lot of storage outside home because of renovations. This is adapted for a repurposed oscilloscope box, the kind of oscilloscope that you plugged into a computer, so it's a fairly narrow box. The original panels went missing, that's why I ended up with the box, so I decided let's 3D print that. But I want to make sure that those brackets, which in fact are not original either, I just used also a bit of a hammer work. But it's similar to the original principle, it just had more narrow ones. So I want to make sure this is not going to break right away. So what I did was added Kevlar reinforcement around all the holes in the material. And essentially this is, even this you can see essentially just on both surfaces. That's already quite enough to make it very much resistant. It's not Kevlar, carbon fiber. We don't have Kevlar yet. This is already quite enough to make it resistant to screwing. A little bit of twisting is not going to make the holes much larger right away. So the only problem with this printer is, as far as I'm concerned, apart from the price obviously, but since I'm at Makerspace who's already paid for it, I'm not concerned about the price. And of course the filaments are more expensive, so this custom PLA they use is about twice as much as the standard one. And carbon fiber is in this printer they're measured by cubic centimeter, not by gram, but carbon fiber is an order of magnitude more expensive than the PLA, so you don't want to use too much of that. One problem is it all happens in the cloud, so you upload your STL to a web interface, they do all the slicing on the interface, and of course the printer actually gets controlled over the internet from the company cloud, which also means the company knows everything in principle that you process in there. But there you go. Another one, this is the latest printer we got in our Makerspace. It's an SLA, so stereolithographic 3D printer, which is the type which is commonly known as resin printers, but we had this video posted to the mailing list by Neil not long ago, where there's a company in the States which makes printers like that working in ceramics. He printed these really nice horns. So lenses for the horns, so as you can see this, but the common ones are run in resin because they primarily print in various resins, in wax and this sort of thing. Thing is that in this case you don't actually have a nozzle which extrudes the filament. You've got a platform which is there, and there is a tank containing liquid substrate, and then the platform slowly lowers itself through the substrate, and you've got a laser beam which solidifies the substrate, also layer by layer. But since we're talking about a laser beam, in this case the layers are virtually indistinguishable. I was going to bring an example print from that printer we have, but unfortunately somebody already borrowed it for showing off. But basically you can't really see the layers on that. And if you want something which is really high precision, say a lens for gigahertz range beam waves, that's probably what you want to do. It is a problem that of course this is much smaller because their laser has got some sort of loss attenuation in material, and at some point it's just not going to go far enough. And there are only certain materials you can work in that. And last but not least, you do have to do some post-processing. So basically this thing came in a set of 3 devices. This is the printer itself. This is the wash, which is basically a big box full of IPA, which also has adjustable platform which dunks the print into it for like I think like 50, up to 5 minutes, depending what exactly you've printed and which material, so that all those loose bits of the solidified resin is, they really go completely solid, and then you can scrape them off and get something nice. And then the last box on the left side would be a curing station, because for instance, if you print in the resin, if you just take it straight out of the wash, it's still going to be quite sticky on the surface. If you really want to have it nicely finished, you have to run it through the curing process as well. But if you do want this kind of high resolution items, it is also very much an option these days. And yeah, in this case though, this is a Formula Form 3B Plus, and it's less proprietary, somewhat less intrusive than the Mark IV, although not by much, because you do your prepping on local software, which is proprietary and doesn't normally run on Linux, although it does run okay in Arden Wine, so I've been able to get away with it. So the Windows interface for Linux, but you still have to upload everything to the online application to run the printer remotely. So yeah, they also essentially know what you're doing. Model mill. This is my personal favorite because I found out it's actually, not only because I'm one of the maintainers of that at ArmXspec, I found out it's really way more useful for radio projects than I expected it to. So it is, well, it's a CNC. That's an important bit because of this bit. And it's quite small, hence the name model, for making models of things. It's essentially like a large desktop size with a working bed relatively small. It's low rigidity, so the hardest thing you can do on that is you can surface engrave aluminium or copper. You can't get into them anymore, it's not rigid enough, but if you want to work plastic, wax, foam, any kind of wood, I think people tried even glass on our machine, they can work okay. The important bit is this precision. So this thing, I think, it's got a resolution of either 10 or 20 micrometers, which is a damn good thing to have if you're really trying to make something high precision, because your wavelengths you work with are really, really tiny. And as I found out, it's in fact tons of things you can make with that, which some of them you could probably get away with doing it by hand or differently. But it does, even if you could, it still helps to have a machine which does that for you. One tricky thing here is that this particular one, at least, it's only it's a free access machine. So you've got the head moving in 2 directions and the bed moving in the third one. There are models with a 4th or 5th axis, so an extra module allows you to rotate the head. But either way, this is essentially what you wouldn't call this as a 3D mill, it's a 2.5D mill. If you want to do 3D, it is entirely possible. This is borrowed from our stage. You have to make sure you align it just right. Then you turn it around. And then you do the other side. So I might see, this is actually, we've got one, this is not this one, but we've got one print bed, which essentially with one bed in the middle, essentially got this holes spaced in irregular distances. So as long as you screw this thing in the right place and then turn it around, you will get rid of the lines, and I guess you get it slightly wrong. For the things that don't need very high resolution, you can always just file it, sand it off later, but yeah. It is quite doable in the end to make some make something really 3D out of that. So just to give you a couple of examples of things I have been messing with on that device. Right, so we had this massive block of not quite sure what kind of plastic this is, but it was lying in the storage room for ages. And then I figured, okay, so what can I do with that? Turns out it's actually very easy to use that mill to convert that, or a larger chunk of that, into that, with very high degree of accuracy because of the resolution. And well, it's important because, just to give you one example, this is from one of the antennas I have built, a room cap, if anybody is familiar with that design, by HB3ABX, I think. So basically at the end, of course, I need to be able to stabilize that. So I did that. So basically it's got it's a single piece, it's not glued or screwed together anywhere. There's a narrower part which slides into the tube and slightly threaded. The top part which then allows you to hold the guying ropes. This is slightly cheated because since I didn't know where our machine does not do 4th or 5th axis, I basically just drilled those holes with a normal hand drill. But in principle, you could do the whole thing on a mill. Another thing also, it's a different, this is the 160 meter room cap, which is 4 meters tall. So basically we only had those pieces of, those structural pieces which were up to 2 meters long. So, and I picked up from our junk box this kind of larger sleeve, like an empty aluminium profile, which was however slightly too large for making this thing sit snugly. So I took the same bit of plastic, I used the mill to mill several chunks. They're actually they're only about slightly longer than what you can see on the outside here because of the limits of how deep the bit can go. But I think they are very precisely sized for both the inner dimensions of the external part and for the actual bar. I did it a bit lazy way because I really wanted to. I could have made it match the slots here. I just actually made the profiles on the corners for it correctly. But yeah, that's like I say, I did put screws on the bolts on that just to keep it more stable. But in principle, it fits very snugly as it is. And actually, not just go to that just yet. And since you can do engraving on that, of metals even, you can do some other interesting things, like you could in principle make PCBs on that. Of course, the method of choice of making PCBs these days is send it off to JLC PCB or whatnot. But if you really want to run something, maybe a prototype, you can in fact do that. This is what they call a V-bit. I'm not going to pass it around because it's really sharp. But you can use that for engraving, and it works very well for engraving. It's basically removing the excess copper from PCB. So I did that. We actually have a dedicated bed for that thing, which allows you to hold the piece of copper in place. And of course, you don't wouldn't be that interesting if you only had the engraved copper tracks. You also usually want some sort of vias, and this is a nice set of drill bits for a model mill. 1 millimeter is the largest. This is 0.1 millimeter. That machine handles those things beautifully. So yeah. The tricky bit in this case is making sure you get your alignment right, but well, that's let's say that's a human part of the problem. And there are different. Our machine is actually relatively under-equipped when it comes to accessories, but there is like very high precision positioning tools for like edge finders or laser-based, making sure your X and Y alignment are exactly right. So if you have access to that, you can really do a lot of tiny and very highly detailed things. Moving on, laser cutters. So yeah, you're probably thinking, at least some of you, oh, that's just for like cutting boxes or whatnot. So yeah, just cut the side, make some slots, stick it together, and it's going to fall apart because all those are rickety, because you got the slots, they're slightly off. There are some interesting ideas you can actually do, apply laser cutters to. Rotary attachments, some of you might have seen them, some of you not. But essentially what you do is that you've got this cable coming out of the motor on the rotary attachment, which when plugged into the laser cutter itself disengages one of the bed motors and then makes the full spin instead. So effectively you convert one of your axes, the axis of the laser cutter into rotation. If you want to make works like, okay, not on a ceramic cup, but if you wanted first to engrave let's say a cylindrical tube when you install your balloon. I thought I had a picture of that, but I must have accidentally deleted it. Then you can really very much do that. One tricky thing is that when you've got this thing rotating, of course it has to be weighted down enough so it doesn't start hopping around and twisting, but not enough that's not going to rotate at all. So it takes a bit of practice. Like that balloon I've just mentioned, that whole print is, the whole label is kind of skewed because I didn't get that right. But it is in fact a very useful tool. I've actually I think I've actually stolen a quote we've got on above one of our laser cutters. Why not use a rotary attachment? Just somebody advertised that. Another thing that I did not personally make, but I know people at our Makespace have been doing that, is that you can in fact make a very fine mesh in a plastic component using a laser cutter. So that guy was building I think it was like a simple homemade array, so and for driver closure, wanted to have there's enough ventilation coming in. So basically, he set up the laser cutter so it fired laser at a very fine spaced mesh all over the box. Works perfectly. Essentially, you're very much limited by the resolution of your device, how fine you can go. Label metal. That's not normally that easy because you have to, in a lot of cases, you have to have a laser cutter which is in fact capable of processing metal, which a lot of them are not because, for instance, as it happens, most of them tend to be carbon dioxide lasers, which, as it happens, are almost perfectly reflected by copper. So yeah, tricky. But there are tags. For instance, I found out it very nicely etches labels in anodization layer, or in a sort of processing surface on aluminium or copper and so on. For instance, the box I've made for my mini tuner, actually I carved everything, all the labels simply by etching the anodization on the panel. Another option is that if you don't have a laser cutter capable of cutting metal and it's not anodized or whatnot, there's another trick. Haven't tried that yet. I know people from Armixis who did. You get this kind of special kind of paint which you slap on the surface, and then when the laser runs over it, it essentially burns very much solidifies solidifies the paint under the laser in a form which is very, very difficult to remove. This kind of paint is relatively expensive, but if you really want like a professional grade colored labels on metal, they work really nice. Okay, so let's say you've also got, you don't want to use your mill for that, and you happen to have one of those reflow ovens, which apparently are relatively common because it's some sort of, I don't remember the name, but apparently some really cheap and nasty Chinese reflow oven, which people figured out how to make cheap and not nasty at all. You have to like replace some fans, reprogram the controller. I think there's some little tricks in there, but essentially you can really make it into a pretty decent decent reflow oven as long as you don't actually need the conveyor belt, because it's this one still you just have to slide the tray out and so on. So of course, if you want to make SMD, you normally put your solder paste in with a stencil, unless you've really got a lot of patience and nerves of steel and haven't drunk coffee for like 2 weeks to make sure your hands move at all. And of course, you can order, you can get stencils made for you along with the PCBs at JLC PCB or whatever online service you use. But then in a lot of cases, you might ask why not just have them assemble the part for you. Instead, it's not going to, okay, it's going to be more expensive, but not by that much. And the thing is, you can in fact use a laser cutter to make yourself stencils rather well. Or you can basically skip that part and, or just if you're doing it through hole, slap some varnish on your PCB, run it through the laser cutter to expose bits you don't want copper on, then dump it into a chemical bath. Very nicely fine detailed tracks. Or if you happen to have a laser cutter which is in fact capable of cutting metal, then you can just make the whole PCB in the cutter itself. These are tricky, I mean the metal capable laser cutters, because among other things a lot of them tend to depend on oxygen supply, and some people for some reason don't like having high pressure oxygen tanks on premises. Like in our case, we actually were denied the ability of do that, so we had to give up on getting a metal capable laser cutter. But yeah, if you're lucky, sky is almost the limit. Not going to talk about these too much, because I'm sure everybody knows who that is. So there's the metal mill, not CNC, but I've heard people converting the Warco CNC mills into CNC with quite a large degree of success. And right next to it, we've got a pretty fancy Warco metal lathe, which unfortunately I didn't get a good picture of, but let's just stick to things. So for certain things, you really need high-grade, heavy-duty equipment like that. And for this is something that's really going to make you happy that you're a member of a makerspace which has these. Because unless you're Neil, the G4GBN, you really typically don't have room or funds to have something like that at home. Just to give you one extra comment, so of course lathes, you can make a lot of things on a lathe. Just to give you something possibly less usual. A couple of months ago I bought on eBay an articulated arm which I wanted to use to convert a salvage laboratory spotlight to work on electronics. It was a really nice articulated arm, made of metal and everything, with this shite plastic nuts on the holding which snapped out right away. So I basically ran this thing through a tube of aluminium, like a rod of aluminium through our metal lathe just to quickly read the replacement. So it's got the thread inside, it's got knurling on the outside to make it whole. This is a bit concave on the purpose because it's going to be a pad of rubber later to hold it better. This surface could have been finished better, but I just couldn't be bothered. So, just to give you an example, it's not all the fancy, high-tech, complicated equipment you can make on a lathe. Something like that is also something. I actually made some standoffs or like a more heavy-duty support, so in electronic system also on the lathe. So yeah, honorable mentions. That something you might not think is a really complicated equipment, but something you definitely want to keep in mind when you do your work. Pillar drill is going to save your sanity more than once, because even if you use the famous insulation tape approach to prevent your drill bit from skidding, it's still not a full-size substitute for having everything like a rock solid in place. Sheet metal bender, another thing I forgot to bring with me. I had made a case for my ports down, which is essentially from salvaged metal mesh, where they were dismantling all the ventilation system and rebuilding and through a lot of that. And thanks to using a sheet metal bender, I got nice sharp edges, and then I made corners to put it together, and then a bunch of standoffs. So you got this whole metal, now a nice metal cage on the back of the touch screen. So I still need to actually integrate it with some sort of arm to make sure we can actually hold on top of the box with the Pluto inside. But it is it's come out fairly okay. If I welded the corners shut, then it would be professional grade. But it's come out pretty nice, and as far as I can see, it's pretty nicely electromagnetically shielded. Arbor press. So if you want this kind of small things like bending things or punching things, holes and things, it's very useful, and it's actually quite small, if heavy. Electric jigsaw, which I actually absolutely love, because as I found out, there are metal capable blades for electric jigsaw, and it's really nice to just be able to run. If you don't need high degree of precision of the edge, how the edge is straight, is just run it through that. And something last but not least, the TS100 soldering iron. There are actually several similar ones these days, like pine seal, but arguably this is the first one like that. It's a really proper soldering iron despite of the size. It can do, in theory, up to 450 degrees on output. I've never managed to get it more than 420. But essentially it's a really small, really capable device, and it does come with a proper set of, it's one of those soldering irons where the heating element is inside the tip, which tends to be a good thing for heat transmission. And it does come with, not by default, but you can buy pretty much all shapes and sizes of tips for that. And I think this one costs me like, 3D printed too, finger guard. The box obviously already mentioned. I think you can get a Pine Seal 2 these days for, which is one of those funny because it actually runs on open source OS for, actually I've got open source OS on that too, because of course. It's called the Iron OS. This one is based on a RISC-V CPU and runs Iron OS by default. It's, I think it costs like 60 quid these days. And for this kind of money, you really can't do much worse as far as soldering irons go. And I think that's pretty much all I wanted to bore you with today. Thank you. Actually I wanted to mention, this is not actually our work. This is something you can, this is from a metal mill. So if you want a high precision of I don't know, a interdigital filter or something like that, of course you can try to assemble it from double-sided PCBs, but you really want like a proper one, then the mill is your friend. Of course, one does have to keep into account that essentially you're buying this massive block of aluminium and throwing all of this away. But for some things you really need that. One funny thing is, so this is okay. This is actually not one made on in our makes, because somebody brought it in as scrap, but. So this one is actually not that smooth. If you run your finger through it, you can actually see where the passes of the bit on this side too. But actually, funny thing is that these things actually remain visible for much longer. They can actually feel the edges. Sort of optical effects on the metal, I presume. But yeah. But yeah, for this kind of thing, you would really need this big thing like the Warco, because it takes a while. On the other hand, if you've got one of those things, then if you can even run HSS steel through that, and well, okay, it needs some cooling then, but it is going to deal with that. And this is another thing from the model mill, where I made myself a base for that room cap antenna, so it stays on the roof. So originally it was like perfectly sized for the inner and outer diameter of the antenna. Then I snapped the middle bit off because I moved the antenna to a slanted roof. So I made it tipped a little bit. So I snapped the middle off, and then I made a bit larger hole at the bottom, just like pushing the antenna further in. But yeah, as long as it was nicely right angled, it was also a perfect fit. And now I think I'm done.
All right. Right, well, thank you very much. I look forward to finding somebody who could do stuff on. Go on, Stuart.
So one of the critical things with all sorts of CAD-based things, particularly 3D printing, is the CAD package you use. I wonder if you comment on your recommendations there.
Okay, so that's, I was going to put a slide on that in my talk, but decided it would be a bit too much, but I am happy to answer that. So I do most of my designs in OpenSCAD. which is solid CAD or 3D, but I would say it's not for everybody, but essentially it's a programmatic thing. So essentially you write code which renders your shape. Which I personally like because it gives me this really nice precision. I can really size everything up at a simple thing, but it does take a bit of a programming mindset to write in that. I did use LibreCAD a little bit, which is more GUI oriented, and it has a nice thing that unlike OpenSCAD, it actually does allow you to deconstruct and then import it STL. So it allows you to actually modify the designs. Because what I did when I made this one, I did it in OpenSCAD. Essentially, I just put the part for the power poles, made the external part, and just added them together. So I didn't need to bother with dismantling deconstructing the original connector, because the whole thing just overrode it. But if you want to modify designs, for instance, resize them, then yeah, well, the OpenSCAD cannot really. There is like somebody wrote a script for OpenSCAD which tries to deconstruct STLs, but results vary. LibreCAD does it better, but I found LibreCAD learning curve quite steep. On the plus side, as I mentioned, we do have a CAD working group in our Makespace, and that's a really good option to learn from people who have possibly been doing that for much longer, how you can do some more complicated stuff. Because, well, I was lucky because I did do CAD at the university, and so I've got some general idea about how those things work. But really, we talked about the tools, but I must say again, the amount of experience you can draw from joining a shared makerspace like that, it cannot be underestimated. Which, of course, a lot of people in the radio community are definitely agree with.
Any other questions? Okay then, right, thank you very much. It's very enjoyable. Right. Who's next? You're next. Right. Gareth, is it alright if I have a plug for you? Yeah.
Yeah, that's just.
I'll clean this up when you're done. Thank you. I think you might want that back too.
Oh, right, yeah. Is that yours as well?
Yeah, I was going to hope somebody can actually help me tune that.
Oh, right, okay.
This is for 10 gigahertz, and I haven't actually got anything capable of.
Oh, right.
The bag was on some.
Okay.
I put it all together, yeah.
Well, I have a friend who has a mini machine on the lathe. Yeah, so that's works well. It gets to do things, sketching quite living and laving. Yeah. 3D printing.
You think about anything you make on a lathe or a mill, you move material.
I can do yes, it's the opposite.
Yeah. And you also have to think, as you mentioned, it's like a piece of wood across the grain, or longer grain, depending which way you're looking at it.
I see my asphalt, so yeah, the point at which it's split.
Yeah. So, for instance, the front panels of that, you wanted the front to look nice, so that is the bottom, and everything else has to be built on the back of it. You can do overhead, but you then have to put support in. You just have to think about how the best way to.
I haven't put the call sign on any of them.
Using the
Shut up. Right, for those of you who don't know me, unaccustomed to public speaking as I am. My name's Dennis Stanton. I'm G0OLX and G8CUX at the moment. So there you go. I do not work for ICOM. I have no association with ICOM at all, but I have known the guys at ICOM for some 40 odd years, and I asked if I could borrow the kit, their loan kit, and they said yes. This was after John BAO had it for producing the Radcom article. I was going to do a similar thing, measuring all the spec and everything else, but he done it for me, so it saved me a lot of time. This isn't really a talk about the ICOM. This is my, how shall I put it, how I find it and how I've found it. I've done a presentation of this at Ofcom to a certain degree and showed them the basics of it up at Baldock. Mainly just to show them what is available out there in the world. They're out there building 10 gig kits and 24 gig kit, putting it up, listening to beacons, and this thing will do it for them. They just need to refine it if they needed to, because it does 5 bands, which is probably unique in the amateur radio market. I've never known anything else do anything on microwaves as much as that. I think I had a 9700, and I think that done 13 SEMS. You could get a 13 SEMS module on it, and so that was the highest I think you could get. I don't think anybody went higher than that, did they? Yeah. Oh, sorry, the 970. Yeah, the big 970. Yeah. So I had one with a 23 SEMS option, but I think the 13 SEMS option was very difficult. This is what you get for your money. 2 meters, 10 watts, SSB, CW, RTTY, FM, AM, and digital voice. Don't think you can do TV on 2 meters. It may do it, but you haven't got enough bandwidth, I don't think. It only covers up to 146, so no. 70 SEMS, you've got the whole 430 to 440 band. 23 SEMS, 1240 to 1300. 23 to 2450. And when you've got 5.6, you've got 5650 to 5850. And with 3 SEMS, it's remarkable, it covers from 10 to 10500. And it would appear that it does work over that range. I think John found that as well in his spec. FM TV is unique in the sense that we don't use it in this country. We're going over to digital television, but unfortunately, but I think they've done a 1296. They've done FM TV on 1296. Sorry, the 970. The 970. They had TV as well. So it's not the first time they've been into TV either. Power requirements 12 to 13.8 volts, up to 5 amps. When I think you go to transmit on the 10 gigs module, it takes you up to the highest current. So that's one thing. It's touch screen. So that means that if you want to change band, you touch the screen, you can select whatever band you want. That's 5600, 1296, 2.4, and you've got 10 gigs. The 10 gigs module's unplugged at the moment, so therefore you can't select 10 gigs. I'll put that in there just to pull it up a bit. Right. Some of its unique properties are that all the RF equipment is mounted at the top of the tower, or your aerial up on the chimney or whatever, and then you've got one cable which comes from there into your control head. The only other thing you've got going into your control head is, apart from your microphone, your computer, is your power lead. So there's no losses on RF cables going up to the top of the hill, top of the mast. So everything is done on a short distance to the aerials from there, which is how we do our amateur radio, but we still normally feed an IF on microwaves up the coax and DC. It's all taken care of in the Ethernet cable. I've been told that some people have actually had it working up to 100 metres, but ICOM do one at 50 metres length, so that's something else. It also has built-in GPS. I've had to put the GPS aerial outside to get lock, but that locks everything onto it. All your frequencies are locked. It comes up and works even out your locator, gives you the lat long, and you can even see the satellites. If you go into quick, press GPS information, that's the view of the satellites you can see. It also updates the clock, so you know that your clock's set, and if you take it off to WXJT or whatever, it will log all the correct times. 2 metres and 70 SEMS and 23 SEMS are all connected via an N-type connector here. So you've got one output feeding 3 aerials. Now some people would say, well, how are we going to cope with this? But you put a triplexer at the top and you can take it out to 3 aerials. So you could have a relay and switch between the aerials, or I think the triplexer I've got has got something like about 0.2 of a dB loss. That's all. So in fact I think it's 0.1 or 0.2 of a dB loss. So it's quite an efficient way of connecting multiband to aerials. The 10 gig unit is an add-on unit, and that takes in the 2.4 gig signal to drive, or the 13.7 signal to make the 10 gigs work. But what that does, it also puts another socket on the 10 gigs unit to feed the 2.4 antenna as well. How are we doing for time? Right, I said that about the separate team 3 SEMS, 13 SEMS. Because how the module is interconnected, it's doubtful that full duplex could be achieved to enable monitoring of transmitted signal via Oscar 100 geostationary satellites. Because that module is feeding, you can actually use it as dual band, but you can't actually be transmitting on 10 gigs and seeing what's going on 2.3, because that's what is being used. You will need to use one of the SDRs online if you want to look at your signal. As I said earlier, there's a very good write-up by John BAO and Dave GKQ in September's RADCOM, which is here. And as I said, they're both, between the pair of them, they've done a very comprehensive write-up of all the specs, currents, sensitivities and everything else. If you don't get hold of that, if you're thinking about buying one, I suggest you do. And there's also episode 19 of TX Factor on YouTube, showing communications between Dave and Noel GTZ. I think it was over a 30 or 40k path, wasn't it? Something like that. It was, but the quality of the contacts were good, and that's using the ICOM aerials, which are vertically polarised, which are not the best. My findings. This is me using it at home, trying to do things which I use my 970 and 705 for. I've got one 23 SEM aerial, and on comparison between that and the 23 SEMS SG Labs transverter, but the SG Labs transverter was better, but not by far, and that was because it's got a much better noise figure. So it was able to detect, I think I was using MHZ at the time, so it's not quite as good as the 23 SEMS transverter, but it's as equal to the 9700. I also used it on 10 gigs as a 2 metre IF using the 2 metre section, and found that performed equally as well as good as decoding the moon beacon as either the 9700 or the IC 705. Unfortunately, when I come to do the testing of a 10 gigs unit on my dish, the beacon has come off air due to a steering fault, and I was unable to include that part to the testing. I wanted to be able to see if, with a low noise preamp on top of the 10 gigs connected onto the dish, I could see the actual moon beacon and see what sort of levels I got compared to the present system I've got, which is 0.7 dB noise figure and with a bit of loss in front of it. This may have been equal to that because I wasn't going to have the loss between that and a low noise preamp, so I've got nearly 2 to 3 dBs of loss before I get to my transverter and also my SSPA. So instead of getting 20 watts out, I'm only getting 12.5, so it's a little bit down. Waterproofing, I think that's going to be the biggest problem. I really do. The 10 gigs unit meant to be IP55, which I think is rain or something like that, but I can't see it's going to be good enough. The design of the actual main unit, where you've got connectors at the top and the bottom, so unless you're going to mount it sideways, is going to make it very tricky to keep the water out of it. So I think it's going to have to be put into plastic boxes of some sort. I'll wait for somebody else to do that. This isn't my kit, I haven't brought it, it's just a loan kit from ICOM. I might one day think about investing, but we'll see. It's nice to have it all in one package. Right, now costings and comparisons. This is an interesting thing. If you buy the actual 905, it comes in a nice box with the head, the cables and the head unit. That costs you £3,549 for a well-known dealer in Staines. No discounts or anything like that, that's the buy price from them, but does include the VAT. Right, so there's another 20%. The 10 gigs option in itself is £1,500, and that gives you half a watt out. So total on all bands, £6,050 including VAT. The only band which isn't there is 9/7s, because I don't think they have that in Japan. So I think that's why it wasn't included.
Yes, I think you're running nuts a bit on the high side there. That's 5K, not 6K.
You what, sorry? Sorry, 5, is it? 3, 4? No, oh yeah, 5K, sorry, you're right. My son's, I only put this together last night, so so okay, there's £5,050. So can I modify it now? But that does include VAT, because that's quite important when you come to considering other bits and pieces. So say for £5,000, you've got everything you want. The alternatives, you could buy an IC 705, but that wouldn't give you 23 cents. If you buy the 9700, you get 2 meters, 70 sems and 23, but you get 100 watts on 2 meters, and you get 75 watts on 70 sems, and you get the same power, 10 watts on 1296. Fortunately, if ICOM have thought about turning the power down, and you can turn it down to 1 watt, and there's no surge at all when you switch it on. That's really, really important when you come to wanting to use low noise preamps and everything. But when you go to transmit, the power doesn't go up to 100 watts before it settles down to 1, because it's going to blow everything else up. But for some reason, this radio, when you set it to 1 watt, you get 1 watt out. If you set it to 0, you get 0 out. You still sit on the spectrum analyzer, but it's hardly measurable. So it's quite an interesting point. Cost of the 9700 from a well-known Staines dealer is, somebody got a calculator. I purposely didn't add this up. I wanted somebody in the audience who's got a phone to do the adding up for me. because you can see my maths is appalling. Right, so that's £1,899.95. So call it £1,900, yeah? Right, transverters. 13 SEMS, which is the band which we need, is an SG Labs, 2.3 to 2.45 using 70 SEMS IF. Output power 1.5 watts, goes up to about 2.5 watts of that power, costs €156, plus €9 shipping, plus duty. I don't know, the duty never seems to be constant. It depends on... Well, you go and tell FedEx that or whatever, because it isn't. The duty is zero, but the rest of you pay the VAT on it at 20%. Right. So, that's the price in euros plus delivery and tax. The Kuhn equivalent, right, is €569 plus shipping and tax. And it only covers 2320 to 2322, whereas the other one does 230 to 2425, which is, you know, wide, quite wide. The 5.7 gig transverter from Kuhn is, again, only covers 570/60 to 5762, gives you 250 milliwatts out, is €850, plus shipping, plus import taxes, I call it, not VAT, but VAT then. Sometimes what's the difference of VAT in their country and then what you pay when it comes here?
We've left the EU, so we're screwed.
We're screwed. So you're paying tax twice?
If we were still in the EU, we'd pay VAT in the country that it was being sold at. Since we've left, we pay it on
Our tax, right. You only pay one in though, you're not getting it double taxed. Is it 1%, is it? We're 19 and they're... Right, 10 gigs. The G5 transverter, giving 10 to 10500, but not continuously all across. You have to go in and change jumpers to give you the various portions of the band, and you get 250 milliwatts output for €715, plus shipping and export. Who was adding it all up? We're up to about 4,000, right, okay. So, remember our 5,000? We're not doing too bad. A few extra add-ons to make the 9700 stable enough to do EME, which is what I like. You've got to buy a GPS reference, a reference injection board which locks it to 49.152 mega. And then you'll need a second reference to do 10 megs to lock your transverters. Would you all agree?
Yeah, the frequency's wrong, but
No, that's the part number. Sorry, I didn't get that bit wrong. Right, so now we've got to add that £27. I think I thought I costed that. It's £139.50 is the monetary value for it. For the Leo Bodner and the board, that's how much it costs. Something's gone wrong with my slide there. Yeah, so that's 139 because they do a module using the single one to feed in, which goes internally, as well as the board and the lead, and that's £139.50. So add that to your £4,000 figure. Right, okay, no. Yeah, plus another second GPS, which is about 110 to lock the 10 megs. But you can't get the 49152 and 10 megs. It's non-devisable. I think people have tried, but yeah, but those two don't do it. Right, antennas. Well, the antennas which they supply, obviously we're not going to talk about 270 and 23 because that's down to you, but they supply little tiny vertically polarised printed circuit boards in a fiberglass dome for about 200 odd quid, isn't it? 300 quid. And now they've just launched I think it's a 30 centimetre dish for about £1,000. So, you know, my 1.2 metre dish, which I use for my moon bounce, cost me £75 from a TV satellite shop. So you really make your own choice about aerials, flat planes, dishes. You can get multi-element feeds. I think you can get a feed which would do certainly 1296 and 13 SEMS. But obviously the lower in frequency you get, the bigger they get, the more you get obscured on the dish. So we're not too far short of a £5,000. We're what, £700 short, say?
You haven't had the PAs yet, because most of those transfers were...
Oh yeah. Well, yeah, but all right. Building these assembles and boxing for mast mounting will require DC cables up the mast, allowing for volts drop. Good low loss cables to get 270 and 23 SEMS up the mast. Even if you put one up there and a relay at the top, it's going to cost you lots more money. 13 SEMS, 5.6 and 3 SEMS should be mounted in the mast and boxed accordingly to prevent ingress. Plus you got time to build it. Right, your £5,000 isn't looking too bad now. I'm not saying you're not going to have to try and add a low noise preamp on it if you want to start doing moon bounce, right? But these things will come along. On my 9700, I have got a DX shop multi PTT, which works by feeding the not CAD, what is it? Yeah, anyway, it takes the data coming back in and it selects which PTT line you want to go out on. It's CAT control, isn't it? I think it's on the CAT. So there's nothing to stop somebody coming up and saying, I'm going to give you 5 of those instead of the 3 I've got at the moment. So I could have 8 coming out, right? And the other thing, I went past it, there's a talk of a 24 gigs module as well. There's another £900 through Kuna for a 24 gigs transfer. Obviously, we haven't got enough details on that to be able to really comment on it, but at least they're thinking about it. So, as I was saying, to improve it, additional preamps bring them up to Kuhn transverter equivalent sensitivity. But if you're going to put into another waterproof box, this would not be difficult to achieve. I believe it won't be too long before somebody brings out a separate PTT. And as I say, I don't work for ICOM. I'm just doing a comparison of what you can get, what's available, and what's in that package you get today. It's got some potential if you were starting from the beginning. Right, I'm not starting from the beginning. I've got a 9700, a 705, 1296 transverter, a 13 SEMS transverter, 3 10 gigs transverters. The only band I don't have anything for is 5.7 gigs. So I've spent one hell of a lot of money over the years, right? Whereas if I was starting today, I know where I'd go, but that's my opinion. So there you go. Yeah. It's got a lot going for it. I can't knock it. And some of the design of putting everything at the masthead and feeding it up on a GAT cable is revolutionary in my eyes. But there you go. It's
There's no separate power. It's PoE. Isn't it?
Yeah, it's power up the Ethernet. This bit does get quite hot because it's boosting it up to 48 volts to send up there. So you've got no DC cables going up there. Everything's being run up like Ethernet. Yeah, there's 2 amps going on receive, but then, you know, yeah. But, right, that's me done. Are there any questions? If you want to buy one now. You what, sorry? Would it make good? No. Oh yeah, tea. Do you want tea? Right. Are we done?
So, folks, that ends the formal part of today. Our approximate times are approximately sort of rightish.
Do you want to finish your last bit?
Yeah, if you want.
Do you want him to finish his last bit?
Would you like to finish the last bit? Do you want to sit and listen to?
What's the time? Hang on.
It's 3:45. We said 4:30 finish.
Will you be done by 4:30?
I should hope so.
Yeah. Come on, he's come all this way. You might as well.
Come all this way, and you're the one we press gang. Everybody else volunteers.
We'll have to load up my show again.
You ought to. Oh, hang on. I'll take it off of that signal because there's a.
I was going to say was we need to thank the club.
Yeah, no, I will do. We haven't finished yet.
No, that's what I'm saying. But
Yeah.
I'm at the back.
Well, you could do that bit. You could stand up and thank the club.
That's what I was about to do. But
Well, let's get you know. Who wants this? Do you want this?
If you want to be able to hear what I'm saying somewhere, online I guess is it?
Yeah, probably.
Yeah. And clip.
Oh, it's £1,000 cheaper than I thought it was. There's a bonus.
what commission are you on?
No? Shall I just flick through? Right, found it. Go.
All right, yeah, okay. Ladies and gentlemen, part 2.
Part several of several. We're near the end, okay, but on the request of filling in a little, I thought, well, I use this stuff for my microwave activities. It's about, it's very much a making side of amateur radio, I think. As in, if you can make it, you can go and use it. It's not an icon. Anyway, 2 meter talkback, right? Back in the day. Where are we on here? It was working. Okay. Where's the IT gone?
Select the window.
Mr. IT man.
Play now.
Right, here we go. Yeah, okay. So back in the early 80s when I first got my license and 2 meters was alive, you could almost work the world on a 7/8 on the gutter. But nothing's got gutters anymore. And although there are ways of mounting the good old trusty 7/8s, which I've still got, I did look around, and those of you who remember John G8MNY, who's still around but is internet non-savvy, nevertheless publishes his amazing work on a site called the Skywaves. Sorry?
MNY, not NNY.
Yeah. Yeah. MNY, yeah, him. Anyway, he designed this. It's a full wave dipole for 2 meters. And he says it's obviously not ideal for portable or whatever. But he did say his matching arrangement, which if you look has got a trombone matching line, a short circuit, a 4-to-1 balun, and then your coax feed, does allow you to match it anywhere. So it's actually really rather good in your loft, because whatever's around it in the loft, you can still get a really good match. And it's a full wave dipole, so it's actually got a little bit of gain, and it's omni. But it's a right nightmare to adjust. And you've got to be able to make a balun and solder the right bits to the right bits and so on and so on. So I built one and tried it, and it does work better than the 7/8. So I thought, right, okay, we'll take this a bit further. So I printed a 3D mount, and I can put it on top of a fishing pole when portable, and it worked. Now, a friend of mine in my radio club, the Surrey Radio Contact Club, Pat G4FDN, he's good at maths, and he loves the theoretical side of things. So he did some maths, and he worked out, but changing the element spacing on this trombone, you could achieve a match and just feed it at the end. Now, I don't understand that sort of maths at all, but I did model what he came up with in terms of dimensions in Managal, and came up with something that looked about right. There's the supposed gain, horizontal plus 6 dBi, omnidirectional, what's not to like. So I built one. Okay, so there's the matching section. It's fed at the end, straight onto the coax with a little choke. 3.2mm welding rods tapped into the end of 6mm rods there. A 3D printed mount, which you can use vertically, or, as I was using it in the 24 gig contest, horizontally. And best DX, I think, Roger, you said you heard me on 2 meters, 120 kilometers, something like that. That's not magical, but it works. It's lightweight, portable, quick to deploy. You can't.
That was on an HP9 CV, that far above ground in a bush.
Okay. Yeah. So certainly when I've used it on top of Walbury Hill, Noel could hear me all over wherever he drove, and I've used it for SOTA and things like that. It really does go well. I've also built a 70SEMS one, which is Tiddly. I use that for accessing GB3 JV, the local DATV repeater, and a 70 meg one, just because I fancied trying it. That is a bit of a heavy beast, but it does work. The trouble is, it's too much for a fishing pole, really. It's a bit wavy-davy if the wind blows. Okay, so that's 2 meter talkback. The next thing is this battery pack, the Fogstar Drift. Okay, now all this lovely stuff needs power when portable, and historically, I dare say most of you have used lead acid in various shapes and forms for portability. Perhaps a little more lithium ion these days, ex-scooter packs or drill packs, that sort of thing with an adapter clip. But lead acid, let's be honest, you get 3 years out of a leisure battery, you're doing well. And when I bashed my finger with my 90 ampere hour leisure battery moving it around, I'd heard about these from M0 DTS, who's got them in his camper, and he just said they're marvellous. So initially I ordered from this company 4 lithium iron phosphate separate cells and a battery management system. And they said it's on back order. This was January this year. So they said it'd be 2 months, no worries. 6 weeks later, they sent a flyer for that, which is a battery management system in it, a heater for when it's too cold to charge, and 4 of the same cells for another 30 quid. So I thought, right, as much as I love making things, I'm not messing with that I'll buy that. So I upgraded my order, and there it is. It comes with a 10-year guarantee, assuming the company's still in business in 10 years. 6,000 charge-discharge cycles, so they're very, very popular with solar backup and battery banks and things like that. Real-life capacity is as stated. I would challenge any lead acid to deliver what it says on the label. And the voltage discharge curve is much shallower.
What voltage is it?
At the moment it's 13 volts, and it's about a third full at the moment. It holds, I've had up to 90 amps out of it into my up converter. So it holds the voltage really, really well under load. It's got a built-in Bluetooth management system which you can look at on your phone so you can see how much you've got left. And it's got a built-in current limit of 100 amps. It is 370 quid, but when you spend 140 or 50 quid on a lead acid and chuck it away in 3 years, and when you look at the improved performance, in terms of charging it up, you can use your decent lead acid battery charger. I wouldn't recommend a bridge rectifier and a transformer. But that server power supply that you showed earlier, I've set one to 13.4 volts. Hook it up to that, it charges at 30 amps, and then it goes down to slightly less as the voltages equalise. So I'd recommend it if you've got the spare funds. Okay, last bit. This is a microwave event, but I thought, why not add the full radio spectrum to a Pluto? Somebody mentioned this on the BATC net last Thursday. It's made by DX Patrol, which is an organisation in Portugal, and it's basically an HF up or down converter. So it shifts the whole HF spectrum up to 80 meg upwards, so you can see it on a Pluto. So anything I can do with a Pluto, i.e. Langstone or Portsdown digital TV, I can now do on HF. Bandwidth. Sorry? What's it called? It's called a Charon, C-H-A-R-O-N. Here we are. It's a small moon of Pluto, apparently. There it is. That's the source. Nothing exotic. It's got PTT in it, both switched and RF sensing. It's got a 50 milliwatt output, so that's quite enough for driving driver amps. No filtering, so same things apply. You're going to need to filter it a little. Some gain on RX and TX. I tried it, it works. I was listening to an AM station on medium wave and equally CW on 20 metres. It was £108 delivered and it arrived in less than a week. And that really is it. I'm done. Okay. You're welcome. 9 kilos. 9 kilos. You can lift it up with the utmost of ease. And I'm not a muscle man.
I've got a 20 amp hour one of those short size. It feels like nothing to pick that up, it's amazing.
I've got this, I think, it's 5 or 6
They've got a little 5 amp hour ones that weigh literally nothing.
Yeah.
You do that by discounting all. I think we really are finished this time. So,
It's even lighter than normal lithium. It's lighter than lithium ion.
wait for Colin to finish. Yeah. A big thank you for all of you for coming, supporting this event. Big thank you for everybody online. Hello. And big thank you to the Crawley Club for hosting us once again. They don't charge us anything. What? Okay, they never ask for money. I think that's probably better than ask money. So, if we could show our appreciation to the Crawley Club in the usual way.
And the biggest thank you goes to Mike, who's been absolutely central in putting this on this year.
Well, I couldn't be bothered hoovering the carpet, so we put a new one down.
Yeah. Okay, no problem. Well, as long as you do it before next year. So, next year, probably about the same time, we'll probably set a date around about March when we decide to bother.